نرحب بكم في أبو ظبي وحياكم في متحف زايد الوطني. اعذروني أن أقدم كلمتي باللغة الإنجليزية، علماً بأن الترجمة الفورية للغة العربية متوفرة عبر الأجهزة لضمان تواصل سلس مع جميع ضيوفنا الكرام. Good morning, Your Excellencies, ladies and gentlemen, distinguished scholars, researchers, delegates, and honored guests. On behalf of Zayed National Museum, it is my great pleasure to welcome you to the 58th Seminar for Arabian Studies. My name is Liga Zaabi, Interpretation Unit Head, joined by my colleague Mohammed Shaheen, Sign Language Interpreter. We are both delighted to share this special moment with you today. Only days ago, on the 3rd of December 2025, Zayed National Museum officially opened its doors. And today we are proud to host this distinguished edition of the seminar within our museum. We are especially honored to be hosting this prestigious seminar in collaboration with the International Association for the Study of Arabia, whose invaluable contribution to Arabian studies over decades continue to shape and advance our studying of the region. This year marks a truly exceptional milestone as the seminar focuses on unearthing history, preserving heritage, enriching humanity. Hosted for the first time in the Arabian Peninsula, in a museum dedicated to preserving, researching, and sharing the rich cultural history of this region. The program brings together research and perspectives that span from Bronze and Iron Age archaeology through pre-Islamic and Islamic periods, all the way to contemporary innovation and the role of technology in advancing research today. I am genuinely excited, and I am sure you will join me to learn from and be inspired by the remarkable discoveries and discussions that will unfold over the coming days. To commence our program, it is my honor to invite Dr. Peter McGee, Zayed National Museum Director, to share with us how openness, collaboration, and the preservation of research form core values at the heart of the museum's mission. تفضل Dr. Peter.
Thank you, Leka, for that introduction. Good morning and welcome to Zayed National Museum. Today marks a historic moment, not only for this institution, but for the wider Arab region. Hosting this seminar here in Abu Dhabi at Zayed National Museum illustrates not just the region's support for scholarship and its growing leadership in archaeology, heritage science, and cultural research, but the growing and across the region, discoveries of global significance are being made, and research teams, local, international, are working together to uncover stories that reshape our understanding of human history. Zayed National Museum was founded with a clear mandate to serve as a national and regional center for research and cultural dialogue. Our work extends far beyond the galleries. It is rooted in investigation and the pursuit of new knowledge. We are building a museum, opened just a week ago, that was founded with a clear mandate, of research activity, but a core pillar of our mission. Whether through partnerships, conservation science, material studies, or historical inquiry, we aim to contribute knowledge that benefits not only today's scholars, but also the generations who will inherit this region's heritage. This year's theme, Unearthing History, Preserving Heritage, Enriching Humanity, captures the profound evolution taking place in Arabian studies. While early research in this region was often defined by simple, single archaeological expeditions, today it is characterized by regionally led collaborations cross-disciplinary approaches, and connections and understanding connections between landscape, community, and history. This shift from isolated discoveries to interconnected narrative has transformed how the world sees the Arabian Peninsula. We now understand more clearly than ever how people adapted to shifting environments, how societies flourished through trade, innovation, and cultural exchange, and how ideas, technologies, and beliefs moved across this region over millennia. The work presented here today will continue to shape that understanding. Just outside this room, the Magan boat stands as a testimony to the power of collaborative research and scholarship. Recreated using traditional techniques and archaeological evidence, this vessel emerged from a partnership with Zayed University and New York University, Abu Dhabi. It demonstrates how experimental archaeology can illuminate early maritime innovation, deepening our knowledge of how people in the region once traveled, traded, and fared across the seas. This is just one example. Our ongoing partnerships with institutions in the UAE and across the region internationally support joint fieldwork efforts, conservation, training, learning, and the development of new scientific methods. Through these collaborations, we continue to study material that expands our understanding of the UAE's cultural history and its role within the wider region. Our mission is to connect people with the deep history of the UAE and the deep history of the wider region. Hosting this seminar aligns directly with our responsibility to support original research, foster public education, and encourage scholarly exchange. To host it now is both an honor and a milestone. It signals that the Arab world is not only a subject of global research, but a producer of global research, a leader in shaping the narratives of its own past. Thank you very much for being here.
Thank you, Dr. Peter. Without further ado, the sessions of the day will focus on 3 parallel tracks. Please take note of Paleolithic and Neolithic session will run simultaneously. One will take place here in this theater that will be chaired by Dr. Emma Thompson. And the second session will take place in the Al Thuraya studio, will be chaired by Dr. Abdullah Sharikh. And we also have these special sessions on Bahrain, which will take place in the conference room, will be chaired by Dr. Salman Al-Mahari. Kindly note that only sessions taking place in the theater will be live streamed on official Zayed National Museum YouTube channels, allowing our wider audience to follow the discussions remotely. For the Paleolithic to Neolithic session, I will leave you in the capable hands of Dr. Emma Thompson, who will be chairing this session here in the theater. For other sessions, locations, our visitor services team is available to assist and guide you for directions should you need any support. Over to you, Dr. Emma. Thank you.
Good morning. I think if everybody who's decided to spend the morning with the Paleolithic is still here, thank you. Then we're ready to get started. As Leka said, my name's Emma Thompson. I work for Zayed National Museum, and it's my pleasure to spend the morning with you all and exploring the Paleolithic. I think it's a great topic, and I look forward to hearing all the new research that's happened over the last year. To start the morning, we have Mark Handel presenting the first paper. He'll be sharing with us the results of his recent research in the Dhafra region. Welcome to the stage, Mark.
So thank you very much. Thank you very much for the introduction, dear Emma. And I am very honored to speak here in this wonderful place. And it's the first presentation even, so I feel a bit overwhelmed. And I would like to first of all thank everyone that was involved for the wonderful organization. We started the Al Dhafra Paleolithic project last January with the aim of assessing previously documented Paleolithic sites and finding new ones. Al Dhafra comprises more than 70% of the area of Abu Dhabi Emirate. Very simplified, it can be said that the region is characterized by the Rub al-Khali in the south and coastal plains with sabkhas and islands in the north. All areas targeted by us are located in the northern part. There are also earlier geological formations, salt domes such as Jebel Danna and Onsir Baniyas, and tertiary formations. And these are of special interest due to several reasons. They represent more elevated areas. The upper layers often have silicate rocks, meaning lithic raw materials suitable for the production of knapped artifacts. And the known Stone Age sites are often situated on or nearby these formations. Upper Miocene formations are preserved in the form of small mesas scattered along the coast, while the lower part of the Middle Miocene formation, as well as older ones, are covered by quaternary sediments, sand dunes of the Rub al-Khali in the interior, and the more recent sand deposits along the coast, as well as coastal and inland sabkhas. The paleontological member of the Upper Miocene in Al Dhafra is the Benuna Formation, while the underlying Shuwayhat Formation is representative for the Middle Miocene. The 8 to 6 million year old Benuna Formation produces the only known late Miocene continental vertebrate fauna from the Arabian Peninsula. Its uppermost part is represented by a caprock complex which contains tabular and nodular cherts. The type site for the Benuna Formation is located at Jebel Baraka. Until the start of our project, the only confirmed Paleolithic artifacts discovered in Al Dhafra were found around the 63-meter-high Jebel Baraka. It occupies the northwest part of a plateau that forms the eastern edge of the 50-kilometer-wide Sabkhat Mati. As an archaeological site, Jebel Baraka was first discovered and published by McBrearty. A first chronological placement remained very careful, considering a Middle Paleolithic attribution possible but not sure. McBrearty also investigated other sites in the area, namely Hamra, Shuwayhat, and Ras Al Aish. These sites are located within a similar geological context. She classified the artifacts collected from these sites as early Holocene. Subsequent fieldwork identified 2 additional find spots at Jebel Baraka, and later another 2 which were published in several articles by Wahida and colleagues. The later publications agree upon a Middle Paleolithic attribution. Most of the artifacts of the later collections were recorded with GPS coordinates. The proposed 5 lithic concentrations are recorded in the Abu Dhabi Historic Environment Record Database as BRK125. The last research incentive into the Paleolithic of Al Dhafra was conducted recently by ourselves. We recorded and analyzed all available artifacts from Jebel Baraka. Only parts of the inventory had previously been presented, while a comprehensive description had not yet been published. Our analysis confirmed an attribution to the Middle Paleolithic. Testing the presence or absence of Paleolithic artifacts was the first step of our field assessment. As stated above, only a single location had been verified before our work started, Jebel Baraka. Since human populations cannot exist isolated and restricted to a very small area, it is obvious that occupation must have ranged into the surroundings. The easiest and most rapid way to proceed is to look for apparently similar geomorphic features and to check these for Paleolithic artifacts. At Jebel Baraka, we quickly noticed that the previous separation in different sites does not mirror the reality in the field. We therefore decided to consider Jebel Baraka as one single site. With our survey, we are able to show that although fine concentrations clearly exist, the distributions are generally rather continuous, both between the previously defined sites and beyond the previous site cluster. Hereby, the site showed being much larger than previously defined, in fact, more than 6 square kilometers. We recorded all the artifacts by GPS coordinates. In the high-density core area, north and northeast of the Jebel's highest points, so that's here in this area, we collected only cores and formal tools, and this mainly along its limits in order to keep the center untouched for the moment. In the site's periphery, to the east, south, and southwest, we focused on assessing the boundaries of the fine distributions. Here, we also collected flakes and debitage in order to have material associated with GPS data. We found lithic raw material in secondary position distributed throughout the entire site. A considerable portion of the nodules was tested, however, by far not all. All raw material pieces show pronounced patina, more than the artifacts. We therefore conclude that the nodules were already in secondary position when the site was occupied. The potential location for primary outcrops at the very top of the mesa had been bulldozed so that primary chert no longer occurs. Artifacts younger than Middle Paleolithic are rare. With less than 1% of the assemblage, the Holocene footprint remains very small. 2 of the artifacts are arrowheads produced on allochthonous raw material, one of which shows an impact scar. In addition, we selected a representative area of 160 square meters in the core part of the site for a systematic collection. That's the photo on the lower right. All potential artifacts were collected per square meter, including tested raw material and debris. The collection targeted not only the material on the surface, but also artifacts from subsurface deposits. These were generally very shallow, ranging between 0 and 10 centimeters. Interestingly, artifacts from subsurface positions are very rare, while raw material was more common. We extended our survey from Jebel Baraka. Hereby, we focused on the northern coastal part of Al Dhafra. Since previous research already showed the presence of lithic artifacts at Shuwayhat and Hamra, this is where we started and continued surveying towards the east until past the town of Mirfa, about 120 kilometers away. We also looked to the west on the other side of the Sabhat Mati. And finally, we also went south where we found a very promising site around a prominent mesa located only 6 kilometers from Jebel Baraka. In total, we recorded 804 GPS points at 11 different localities. As you can see on the map, most locations provided either Holocene finds or none at all. We found Paleolithic artifacts at 4 localities, including Jebel Baraka. The directions to both the east and the south seemed promising to some extent, while we found no artifacts of Paleolithic character on the left bank of the Sabhat Mati. The overall studied corpus of collected artifacts comprises more than 3,000 pieces from 8 different localities. Objects that can be assigned to the Middle Paleolithic dominate, while Neolithic and unspecific Holocene lithics are much less abundant. Flakes and debitage make up the largest part of the assemblage. We recorded more than 500 cores, while debris makes up a smaller portion with 136 specimens. Compared to the Jebel Baraka assemblage, the inventories of the other sites provided significantly fewer artifacts, with a total of only 74 pieces. Only 3 other locations provided artifacts of Middle Paleolithic character: Al-Ga, Shuwayhat, and Barka bint al-Faha. The Middle Paleolithic inventory from Al-Ga consists of 1 parallel surface core and 2 undiagnostic flakes. The inventory from Barka bint al-Faha is somewhat larger and includes 28 Middle Paleolithic specimens, consisting of cores, preparation debitage, and flakes. The inventory includes the entire chaîne opératoire for flake production on surface cores. In addition, there was also a notched piece. In sum, despite the small size of the lithic inventories, we can draw some conclusions. Al-Ga and Barka bint al-Faha document on-site production of flakes from locally occurring raw volumes. The relatively small number of artifacts indicates single short-term occupation events. 2 artifacts from Shuwayhat show Middle Paleolithic character, but do not allow any further interpretations. The selective assemblage collected at Jebel Baraka includes 2,378 artifacts. 411 pieces, including all cores and types, were recorded and analyzed in detail. For the remaining blanks, primarily preparation debitage and flakes, only the chronological classification and the weight of the respective pieces were determined for the moment. The vast majority of the inventory can be assigned to the Middle Paleolithic, while the portion of Holocene artifacts is very low, with a total of 16 objects only. The remaining 396 artifacts assigned to the Middle Paleolithic are obviously, due to selective collection, dominated strongly by cores. The typological spectrum encompasses 16 objects. The types can be divided into 3 basic groups, each reflecting different functional aspects. Hammerstones represent on-site production of targeted blanks and tools. Levallois points can be assigned to armatures and probably related to hunting activities. Types such as side scrapers, notched pieces, denticulated pieces, or laterally retouched pieces represent domestic activities carried out on site. The bar facial artifact may be of particular significance, as its morphology appears similar to the bifacial elements from assemblage C at Jebel Faya. Our core analysis shows the predominant use of raw volumes as cores. Thick flakes were used only in some cases. Among the core types, parallel surface cores dominate. Inclined surface cores and discoidal surface cores occur in significantly smaller numbers. In addition, a relatively large number of tested raw material pieces were documented, showing only a few reduction negatives and attesting to the very initial core preparation stages. The negatives on the reduction surface of the surface cores clearly show that blank production was focused on flakes, while blade reduction, there's one example down here on the left, is very rare. For blank production, the raw volumes were prepared differently depending on their initial shape. Centripetal reduction patterns predominate, but orthogonal, unipolar, and opposed reduction negatives were documented in significant numbers as well. Preferential reduction accounts for over 70% of the surface cores, whereas recurrent reduction only plays a minor role with 10%. The inventory also contains 28 cores that have more preparation negatives than tested raw materials, but lack targeted reduction negatives, and therefore can neither be assigned to the preferential or recurrent reduction method. We classified them as initial reduction phase cores. The systematic collection comprises all artifacts collected from the 160 square meters. This provides a technological and typologically representative character and allows for broader conclusions on fine distribution and density. The systematic collection includes 731 Middle Paleolithic artifacts. Preparation debitage makes up the largest part of the inventory, accounting for almost 60%. Debris, meaning fragments that only emerge during the reduction process and do not have a clear dorsal surface, comprise 19%. Cores account for 14%, while targeted flakes for 8% of the assemblage. Analysis of the 102 cores shows that exclusively raw volumes were used, while cores on flakes are not documented here. Tested raw material pieces with only a few preparation negatives account for the majority among the core types. Parallel surface cores make up 22%. In addition, there's one discoidal surface core. Blank production on surface cores aims exclusively at the reduction of flakes. The direction of the preparation negatives predominantly shows a centripetal or orthogonal reduction pattern. Preferential reduction accounts for over 78% of the surface cores. Recurrent reduction could not be documented. Some specimens demonstrate preparation after the removal of a targeted blank. This illustrates that multiple targeted blanks could be produced per core. The ongoing preparation process can also be documented on the basis of two refitted artifacts. On the upper right, you can see that. Following the removal of a targeted flake, the lateral face of the core was partly removed to create a new striking platform for potential further reduction. The ratio of exploited surface cores to other blanks shows the following composition. One surface core is accompanied by 4 tested raw material pieces and cores displaying the initial reduction phase, 3 targeted flakes, 24 pieces of preparation debitage, and 7 pieces of debris. The tool inventory includes 5 artifacts, which corresponds to 0.7% of the assemblage. The average fine density is about 4.6 fines per square meter. The distribution of the total weight of lithic fines in kilogram per square meter shows several particularly dense zones, especially in the southern half of the sampled area, and ranges from 0 to 1.4 kilograms per square meter, corresponding to an average value of 300 grams per square meter. The 102 cores occur between 0 and 3 times per square meter, which translate into an average of 0.6 cores. Preferential cores average at about 0.1 per square meter. On the basis of the technotypological analysis, Jebel Baraka clearly represents a Middle Paleolithic raw material procurement site. The study shows that all stages of the chaîne opératoire were carried out on site. The preparation process starts with the removal of flat lateral areas and smaller finger-like protrusions from raw volumes to obtain a piece suitable for further processing. Subsequently, the striking platform and the reduction surface are prepared by removing the natural surface. The direction of the preparation negatives shows various patterns, with centripetal and orthogonal reduction predominant. The subsequent blank production on cores aims mainly at the reduction of flakes. As a result, the targeted flakes exhibit a relatively homogeneous morphology. If possible, cores are further prepared after the reduction of the targeted flake to obtain further flakes. Due to the limited thickness of the raw volumes, the majority of the cores were prepared as parallel surface cores. Inclined and discoidal cores require larger thickness and are therefore less frequent. In a few cases, thick flakes were also used as cores. A significant number of raw volumes were tested and exhibit only a few perforation negatives, direct hard hammer percussion, and to a lesser extent, soft hammer percussion represent the main reduction techniques. The typological inventory is rather small, reflecting the limited range of human activities. Domestic tools occur, but do not represent systematic, frequently repeated activities, but rather stand for singular events. Les Valois points are present, but likewise in small numbers. It can be assumed that both points and targeted flakes are clearly underrepresented, implying that these artifacts were transported to other sites for later utilization. The vast spatial extent of the site and the high find density clearly suggest recurrent occupations at Jebel Baraka. As a key location for the supply with lithic raw materials, the site appears to have been an essential point in the economic network of hunter-gatherers and certainly had a significant impact on their mobility patterns. Given the narrow typological spectrum and the resulting limited evidence of both diversity and quantity of human activities other than lithic manufacturing, it seems obvious that there must be other Middle Paleolithic sites in the region filling this functional gap, particularly with regard to food provisioning and processing. The lithic inventory thus indirectly illustrates the potential of the adjacent area for locating further Middle Paleolithic sites. This can already be demonstrated by the initial results of our recent field surveys. Artifacts from Barka bint al-Fahar, Shuwayhat, and al-Ga point to a broader, more extensive prehistoric landscape than hitherto known, reflecting denser Middle Paleolithic land use patterns. The Middle Paleolithic technocomplex represents the only Pleistocene industry attested, as there is no evidence suggesting earlier or later Paleolithic occupations. On the basis of the available data from the regional Middle Paleolithic record, we propose two hypotheses for a chronological placement of the inventory. A regional model, occupation at Jebel Baraka, corresponds to one of the occupation phases at Jebel Faya, horizons 3 to 7, all of which feature centripetal Levallois cores. In this context, the bifacial piece from Jebel Baraka corresponds most closely to bifacials found in horizon 4. For this layer, OSL samples exhibit a mean depositional age between 127 and 141,000 years, and thus a chronostratigraphic placement in MIS5E. As there are no technotypological connections to Jebel Faya horizon 2, an attribution to MIS5A can be probably ruled out. The second possibility, a supra-regional model. Jebel Baraka is linked to the Middle Paleolithic human presence in northern and central Arabia. The site reflects ecologically favorable periods during MIS5, so E, C, and A, which allow increased mobility and intensified supra-regional linkages. Taking into account the sites with similar technology in Saudi Arabia associated with MIS5A, this phase cannot be excluded as a potential time for human presence at Jebel Baraka. In the absence of chronometric data, the question of a secure chronological assignment for Jebel Baraka remains unanswered for the time being. Nonetheless, our investigations indicate a great inherent potential for further research, which may contribute getting a better understanding of human presence during the Middle Paleolithic in the region. Thank you very much.
Does anybody have any questions for Mark?
Would you think that sea level change has maybe something to do with the pattern that you see in the lithics that you find, that you miss some certain periods, for example?
Thank you very much for this question and for your comment, yeah, which I absolutely agree, but thank you very much for pointing this out. Of course, both options are possible. Yes, this may well be the case. As we know, there does not have to be a very strict correlation between environmental conditions and the sea level or the actual sea level. So when environmental conditions improve after a previous deterioration, it takes some time until the sea level rises again. So people move faster than the sea level rises. And therefore, it is absolutely possible to find that there is a possibility that a part of the economic network we're still looking for in the Al Dhafra region is presently submerged.
Sally McBrearty also collected material at Hamra. I know at the Hamra locality you still have access to some of the flint chert still sort of in situ. Do you think that there's a possibility there of somehow getting some chronometric dating there where you still have some in situ material and stuff? And you didn't really mention much about Hamra. I think there's some similar material there. I know that there's some later material, more Neolithic material there, but is there any similar material there that you looked at as well?
So we looked at Hamra. It is a very extensive site. We spent some time there, and there's a lot of raw material. There's a lot of the cap rock preserved or just collapsed. So we have flint nodules of up to 50 centimeters in size in some places. In the greater part of the area, I didn't show this now, there's a lot of what I call thermo shatter in the area. And there are Holocene artifacts, so there was Holocene occupation for sure. We did not come across anything earlier. But I have to say, there's a restriction, of course, because Hamra is so extensive. It is very well possible that we did not see everything, and we certainly did not see every single square meter.
I think it's still worth to have a more detailed look there. There might be some possibility.
Definitely. We wanted to get, so our aim was to get a big picture first before looking into details. Thank you.
I think we need to move on to the next speaker now. Thank you, Mark. The second speaker for this morning is Dr. Bretka, who's going to give us this is of the last 2 decades of research in the Paleolithic. So I look forward to hearing that. Thank you.
Yeah, good morning, everybody. First of all, thank you very much for having me here in this wonderful meeting. I so far really enjoyed the organization and everything. And I look forward, of course, to hear more about the latest results from Arabia. Today, I would like to reflect on, let's say, my time in Arabia. And I will kind of wait for my presentation to show. Do I need to do anything? Forward? Okay, sorry. 2 decades of systematic Paleolithic research in Southeast Arabia. Where do we stand? As I said, it's a kind of a reflection on my time in the region and how things developed during that time period. When I came here first in 2004, and I did my PhD in Syria, so there was lots of Paleolithic research in sites in Syria, of course, and kind of bit surprised to being confronted with the situation that we have almost no Paleolithic sites. And while saying this, of course, and I show you here two papers from Petraglia and Al-Sharek from 2003, they summarize what was known at that time in Arabia. And you see there are lots of dots for the lower Paleolithic period and the middle Paleolithic period. And I added a few, and I added Jebel Baraka over there because that was missing. But yeah, so it seems there must be lots of evidence from the Paleolithic period in Arabia. But if we go in further detail, we will realize that most of this, or actually all of it, wasn't stratified, and we have no idea how old it is. So we see we have some sites from the different time periods, and I show you here the different phases in the Middle Paleolithic, Lower and Upper Paleolithic periods. And I show you three examples on the right side from sites that were considered to reflect this phase. And I focus here, of course, on the sites that are located in the southeast, except for the youngest one. Obviously, there was not a single surface site that has been classified as Upper Paleolithic. There was only Farwell site that was supposed to be Upper Paleolithic. But as I said, none of these sites was dated, so there was no chronometric control of this classification. And then in 2011, Jebel Faya was published. Of course, we already knew from 2006, we started excavating, I have to say Hans-Peter Obmann, of course, started research at Jebel Faya. He realized that the site has great potential to find stratified material from the Paleolithic period, and he conducted excavation. And we started in 2003, and I think it was in 2006 that the first Paleolithic tools were excavated. So, and then it took a while to get the dating sorted and everything, so it was published in 2011. And you see here an aerial view of the region. So we are on the northern end at Jebel Faya in the central part of Sharjah. And I probably don't have to say much about Jebel Faya. I have presented the site several times at this meeting, and Hans-Peter always talked about it also. So you know there are two different sequences. One is the terrace. This is more the trenches in front of the shelter. And we have the shelter sequence, which is actually below the current shelter. We have dates from the two sequences, OSL dates, and these are also stratigraphically correlated. So we are actually quite sure about chronology, which is here. I show you a kind of overview of what's going on. We have multiple papers describing the sequences, and what we see is recently we published the oldest assemblage D, which was dated to 210,000, and we believe that this is the first occupation phase at this site. Then we have one very interesting layer, which is AH7, the difference between assemblage D, ABCD, and AH1 to 7 is that the AH nomination goes for the shelter sequence and ABC is the terrace sequence. But yes, you see here we have one from 170,000, which is actually interesting because this falls in a time period when it was thought that it was too dry in Arabia, that we have human occupation at that phase, so we also found in this period something. Then we have the classic sequence assemblage C, B, and A, where C was dated, as Mark already mentioned, into the time frame 125,000 years, and then B is undated, and assemblage A was dated to a younger period, but we are working on the on that day to make it more sure that we are talking about that. And then we have a late Paleolithic, very early Holocene Fasato horizon on top of that. And you see the shelter sequence squeezes in there. We have the late MES5, MES5A layer 2, dating to 80,000 years. And I think we're going to hear about that layer in a talk, another talk this morning about more details. So we have a quite good sequence here, actually covering MES 7, 6, and 5, and then it stops, actually. As I mentioned, we no longer believe that assemblage A is dated to 40,000, and because the stratigraphic sequence suggests that is also part of the MES 5 sequence. Then I remember quite a number of years ago, I was asked by Abdullah Al-Sharek if I would expect another Paleolithic site in the Faya range. And at that time I said, no, I'm not sure if we find anything else, because every year we were there, we did systematic survey, we went in all little valleys, and we ran all around the Jabal, and I said no. Well, time goes by, and then other opportunities occur. Isa Yusuf, the general director of Sharjah Archaeology Authority, brought me to the Jabal Buhay's rock shelter, which you can see here on the lower right. And it was known for Iron Age burials. And since he knew that I'm always looking for some stratified sediment or sediment traps, he brought me there asking me, wouldn't you think that it's interesting to check whether there is something? And I said, yes, of course. As you can see, maybe in front, you see the little rock shelter there, and there is indeed some sediment trapped in front of that. And so, yeah, we started excavations there in 2017. We had the first test excavation, just 2 square meters, just to see if there's really anything in the ground. And we didn't have to go deep to hit the first layer that was exclusively composed of stone tools, or lithic artifacts, I have to say. Of course, they're not all tools. And this normally indicates that you're in the Pleistocene. Often, at least in those sites I have excavated, it's often the case that you don't find anything else than stone tools. So I was a bit optimistic that we had reached the Pleistocene, and it turned out that we were right. At the end, we excavated, as you see, a number of years there. In the following years, we extended the excavation trench. It ended up to be 3 by 6 meters, and we went down about 1.70 meters. And the youngest layer, we collected lots of OSL dates. Again, unfortunately, there was no charcoal, no fireplaces, anything like this. So we had to rely on optically stimulated luminescence dating to get an idea of how old the material could be. As you see here, we have 4 layers. You see the different dots. Blue and yellow turned out to be Middle Paleolithic. Yellow is same age as Faya C, so 125,000 years. Then we have a very interesting, the red layer is late Middle Paleolithic, dated to 60,000. And then we have 2 upper Paleolithic layers in that site, and with typical upper Paleolithic material culture, as you would expect from other areas that have more sites that reflect upper Paleolithic occupation. So we were quite happy with that because there are not many Upper Paleolithic sites in Arabia. There's actually just one, which is, at least as it stands in its publication, it's just a test excavation, relatively small lithic assemblage, but it dates to 33,000. We now have the green layer here dates to 35,000 and the blue one to 16,000. So we have two Upper Paleolithic layers and two Middle Paleolithic. So we have the transition from the late Middle Paleolithic to the Upper Paleolithic, which is again an addition that we so far have not from any other place in Arabia. So that's interesting. So you see the finds are the numbers are quite good, 3,000. I mean, that's in total, but in general. So I think we hear about the site in the other talk. We are about to publish this, as you can see down there, and I hope it will come out very soon, so to give you all the details. Okay, here we have a quick overview of what's going on in terms of lithics. We see the late Middle Paleolithic, it dates to about 60,000. It's mainly its main characteristic is that we have no Levallois, or at least almost no Levallois technology. We have a strong tendency towards lithic artifacts with converging edges, so pointed morphologies. And then we see a clear break in terms of lithic technology. We see the early Upper Paleolithic where we have, and the Upper Paleolithic is famous for blade and blade production. And what is a blade? A blade is a lithic artifact that is at least twice as long as wide. And it has, at least an Upper Paleolithic blade has normally two parallel edges. And to produce that in series, I mean, they have technologies that allow them to a serial production of elongated, parallel-sided, thin artifacts, which we call blades. And if they are narrower than 1 centimeter, then we call those bladelets. And you see the blades coming in at 35,000 AH1A. And then in the younger Upper Paleolithic, we have a stronger focus on bladelets, so the smaller blades, so to say. So that's all quite new, and as I said, not published yet, but I'm working on this to make it available for everybody of you in more detail. What always goes in parallel in our projects in FIRE in Sharjah is that we have our colleague Adrian Parker with us, and he's doing paleoenvironmental research. He's not only trying to squeeze out some paleoenvironmental information from our archaeological sites, so we can directly correlate archaeological horizons and paleoenvironmental information, which is not easy because, as I said, normally we don't have anything like stone tools, and organic preservation is terrible usually. And so he tries to make some conclusions from sediment, grain size, and geochemistry and things like that. So in addition to this paleoenvironmental research at the sites, Adrian also do some field work in the region where we excavated a number of these sections where he tries to get an understanding of the local hydrology, hydrological system, the chronology of wet phases and reactivation of wadis and these kind of information we try to squeeze out. In our latest edition is this on the right side here, which is a beautiful stratigraphy because the colors tell you the depositional environment, you know, and that's kind of very interesting. Of course, it's just when it's fresh, it looks like this, but you can easily distinguish phases of sand deposition, which are the red sands here, and then you have phases of wadi depositions, which you have small gravels, and then you have phases of deposition of fine-grained material, whether you call it lake phase or standing water or whatever, but it indicates a change in the local hydrology. So, and of course, all this can be dated very nicely, and so we have a very good connection between the archaeology and paleo-environmental conditions in the region. And here, yeah, I can show you one of these interpretations, and this is the color one that I was just talking about. You see there's quite a number of places where we collected this type of information, and on the right you can see it covers nicely the phases where we have human occupation, and so we can estimate the situation. And what came out mainly is that it's more about the local environmental and hydrological conditions rather than global proxies deduced from ice cores or whatever, or deep sea cores also, that matters in terms of human occupation. Because this, while our data, our occupation phases do not correlate very well with the global signal, indicating that during hyper-arid phases we have occupation, which would make not much sense. No, it shows that we have locally in these global hyper-arid phases, we have locally the situation that we have the reactivation of wadis, we have active springs, which we can deduce from spring deposits, tufa formations, and so on. So that needs to be considered when you talk about the overarching topic or conclusions at the end. And yeah, all this together, the incredible record in terms of archaeology, the incredible record in terms of paleo-environment, led at the end, and I'm sure most of you will know, to the enlisting of Jebel Faya Paleo Landscape as a World Heritage Site earlier this year. So we have now the second World Heritage Site in the UAE. Al Ain is the other one. And so that was a great achievement. And of course, it puts now the focus on the region and to better understand everything. And of course, also on the Sharjah government to protect everything. And you all know the difficulties that go hand in hand with the inscription in the World Heritage list. Anyway, it is a great achievement for the region, a great achievement for UAE to have a second. And in terms of Paleolithic, there are not too many sites on the World Heritage list, so that's really an important point. Okay, yes. Of course, I was fortunate not to exclusively work in Jebel Faya all the years. As I said, I came first year in 2004. There was a little break in between. I came back in 2009, and from then onwards, I was here almost every year. And I had the situation that we were able to excavate also other sites. But first of all, I would like to mention this general situation in Southeast Arabia. Of course, we know Faya and Buhays, I just presented, Jebel Kafador and Ibri Wadi and Ibri Hochshelter I will talk about in a minute. These are other sites that I was fortunate to work on recently. And of course, we also have Jebel Barakat. We have just got a great overview of the sites by Mark. And the Hafid records collected on surface also by the team, I think directed by Mark, or at least presented by Mark recently and published. So we're getting better in Southeast Arabia in terms of Paleolithic, but still the red ones, and also I have to mention Suhaila, where we found Julian Hendex, again, just on the surface, but we're working on that, and I'm pretty sure at Jebel Baraka, one day we will find a moment or situation where we can do some chronometric work on these finds. Maybe you just go underwater and dig there a little bit, and then you find something. Anyway, just I need to go back to my topic. Jebel Kafador in you see here in Fujairah. There was a nice little rock shelter. It was at Adrian's heart for many years. He knew the rock shelter for a very, very long time, and it is in the center of a limestone quarry. So it was just because you see this little tree standing in front. It was just because the tree was growing there that the site was not quarried away. And Adrian, I can't remember exactly, and I can't see Adrian in the audience, went for what, but really long time he know that site, and he was always trying to find someone to excavate. And in 2019, we had a chance to do a little test excavation there. Again, we excavated a small-scale area, 6 square meters, and you see here the excavation plan. It's a nice little rock shelter. We did some 1 by 1 squares and 1 by 2 squares, 2 of them. And so we went down a little bit, and we hit bedrock relatively easily. The site turned out to be very interesting, although we are quite narrow sediments and difficult to excavate, or difficult stratigraphy and things like that. But what is interesting is we have lithic artifacts with a great, as you can see here, these lithic artifacts, they have a diversity of lithic raw materials. So that's nice. And not all of them come from the region, so they must be brought there. So you see we have nice striped ones, dark black ones, brownish, and different things. But what's probably much more important is that we do have bone preservation. And that is outstanding. I told you earlier that I have never seen any bone preservation in something Pleistocene. You find that in the north, in Saudi, in North Saudi, there are some deposits. But in the southeast, there's not a single bone in the Pleistocene sediments preserved. And here we have, and I told you that we dated this layer to 13,000, so that's late terminal Pleistocene. We just got a few lithics. You see 125 in total. You see we have 3 layers, 7,000, 11,000, and 13,000. And these bones come from the lower 2 layers. So earlier, let's say, either you call it early Holocene or really terminal Pleistocene. Anyway, you got some bone preservation there. And that's the point here. And we have multiple bones. And the bones are clearly old because the organic material is calcified and all these things. So there's a good chance that we have some Pleistocene bones. But of course, we would need to go back, and this is at the moment a little bit difficult, but I hope that we can create a situation in the near future where we can continue excavating there, collect more samples, get more dates, and of course get the bones identified and get more bones. So that's the one exciting site I was able to work on. The other one is Ibri Rock Shelter. I had a chance to work in Oman. It's just, actually it's not too far from Al Ain, so you just go around the corner, follow the mountain range, and you end up in this little rock shelter. And again, we did a little test excavation in 2019. 3 square meter, 60 centimeter down. We didn't reach bedrock, found 125 pieces, and we have, what's interesting, you see the facade point here, that is from the layer 10,800 plus minus. And that's interesting in itself because it provides the possibility to have a facade assemblage if we continue, if we are a bit lucky that it's not a single find, we may get an understanding of the lithic technology surrounding the facade phenomenon. Could be interesting. And for me, a bit more interesting is the 30,000 layer just below. Again, it's an Upper Paleolithic age, and would be interesting to continue there, of course, and since the Upper Paleolithic is so few in the region. Then we have another dated site. This was just around the corner, Jebel Ibri rock shelter. So this was together with Sam Wurr and Ash Parton. They did some paleo-environmental work in the region, and they found this nice little hand axe here stuck in this sequence over there. We were able to date that, and we found out that this dated between 370,000 and 300,000 about. Was this hand axe deposited there? Is not saying necessarily that was the age of the production and use of hand axe, but we have for the first time a Lower Paleolithic dated artifact from Southeast Arabia. So I just wanted to mention that. So we really work hard on providing some chronometrical data on archaeological phenomena that are, some of them are already known, some of them are new. So of course, the rest of Arabia was not lazy at that time. In the time frame I'm talking about, there's lots of big projects running through Saudi mainly. The Queen Arabia project, Abdullah al-Sharek is unfortunately in the other room, but they found great, interesting stuff. So footprints, the one and only human bone from Pleistocene context in the north of Saudi, and we have Shiba Diha in Yemen, a very important site dating to about 60,000, 55,000 years ago, and of course a whole range of sites in Dofa and Safon, Oman, in Jama. You have been there and were part of the production of all these wonderful data sets. So we're getting better, I would say, although we are still just a few people considering the size of Arabia, and we are getting better. So just a quick reminder of where we started. I know Southeast Arabia dated Paleolithic sites. I told you Jebel Kafador, rock shelter, Buhais rock shelter, and so on. You see, we filling in the gaps, Middle Paleolithic evidence, some Lower Paleolithic evidence, Upper Paleolithic, and of course then we go into the Late Paleolithic. Conclusions. Well, achievements. What did we achieve? Significant process over the past 20 years. I hoped I could convince you that we really add some important data. And of course, it's not just me doing all this work. I try to show everything that I am aware of from Southeast, at least. The record, we now know records from nearly all periods. Still, there's lots of detailed questions open, of course. But to demonstrate that all periods are here and that there is a chance for dating the different things, maybe not always in an optimal way, but we get our hands on the topic, and if we just continue, I'm convinced that one day we get a well-developed, and I'm finishing very soon, well-developed chronostratigraphy of the region. Yeah, and it turned out Southeast Arabia is one of the key regions in Arabia, more or less complete record from Lower, Middle, and Upper Paleolithic. So, and that in a relatively narrow area. You know, if you consider Saudi, that's a huge area, and all the sites are spread all over the place, and you found one here, one there, one there. And here in Southeast, we are a tiny subset of the Arabian Peninsula, and we have everything in a small area. That gives us the chance to better understand the paleo environment, the interconnections between environmental chains and human occupation. What are the challenges? Just quickly, well, diversity in Paleolithic traditions need to be better understood, which means we need more sites. Remaining gaps need to be filled, that's obvious. The role of climate and natural environments as factors for human settlement and cultural evolution needs to be further explored. Understanding Pleistocene flora and fauna and their response to climate change. That's a big challenge because, as I told you, there's almost no organic preservation in the Pleistocene sediments. Of course, none of my work is doing on my own. I thank all of these institutions and all the people that are linked to these institutions to help me with compiling these data and continuing with my research. Thank you very much.
Difficult to fit 2 decades of work into 25 minutes. But I think that means we don't have time for questions. We can have them at lunchtime, maybe. Yeah, exactly. So we'll move on to the next speakers. We have 2 people presenting the next session. We have Mariam Lehleli and Yvette Kujani, and they'll be presenting discoveries in Shauka in Ras Al Khaimah. I'm not sure who's going first. No problem. Okay, yeah. I have been told there's a little timer at the back there, but I can also give you a warning. So, thank you very much.
Okay, thank you. Okay. So good morning, everyone, and thank you for the kind introduction. It is the pleasure to be here today to present how an ordinary archaeological task unexpectedly led us to reconsider the early human presence in Ras Al Khaimah. During the Etihad survey in Ras Al Khaimah, During the Etihad survey in Ras Al Khaimah, led by the late Tibor Paluk, a group of Paleolithic stone tools was identifying in Shauka, a discovery that may open a new chapter in the prehistoric timeline of Emirate. In this presentation, we highlight 2 integrated aspects of the project. Firstly, the archaeological significance of the Khadra finds as evidence of the earlier habitation. Secondly, the museum perspective, how these artifacts move from field discovery to the public display, forming a new narrative within the National Museum of Ras Al Khaimah. Through this lens, we explore how interpretation, context building, and exhibition strategy influence both public and local understanding of long-term human history in the Emirate. The Arabian Peninsula has long served as a crossroad between Africa, Europe, and Asia. Evidence for Paleolithic occupation in the UAE is limited but significant. For the lower Paleolithic, we mainly have ocean surface find associated with the old. It's okay, it's much better because I would like to see as well. Okay, thank you. For the lower Paleolithic, we mainly have ocean surface find associated with the lake system. This suggests early hominin presence or movement across the region during these periods. In contrast, the Middle Paleolithic, as you could heard, is the most extensively represented phase with numerous sites recorded across Arabia, including along the southern dispersal route in the region of present day in Ras Al Khaimah. Not working with the poem. The pointer is not working. No, the pointer. Yeah, the laser pointer. Okay, doesn't matter. Okay, back. So the final stage, the Upper Paleolithic, is extremely rare in Arabia with only limited and localized evidence for human presence during this period. Research on the Paleolithic in the UAE has been shaped largely by discovery outside the Ras Al Khaimah, particularly in Sharjah and Abu Dhabi. The most influential site in Jabal Faya were satisfied lithic assemblages demonstrate repeated human presence during the late Pleistocene. The assemblage at Faya, including bifacial foliates, Levallois cores, and the unidirectional blade production, suggesting technological links with Northeast Africa during the humid climatic phases. I'm so sorry. However, only limited evidence of Paleolithic activity has been identified in Ras Al Khaimah. The region is dominated by surface finds, often heavily weathered and lacking secure stratigraphic context. Previous interpretation of early human occupation in Iraq have therefore relied mainly on Neolithic sites, such as Al Jazeera and Khat, which provided the earliest secure archaeological horizon until now. Between November 2019 and January 2020, our team carried out the archaeological survey for the Etihad Railway project, covering more than 260 kilometers across the Ras Al Khaimah. One of the most striking zones along the southern part of the route, that was the Qadra Shauqa area, set on the western flank of the Hajar Mountains, right where the foothill drops into the upper reaches of Wadi Shaka. One on the limestone plateau cut by the modern Qadra Road, we identify a cluster of features, 3 shallow rock shelters, and more importantly, 2 dense surface scattered lying along the plateau's margin. The raw material stood out immediately. The limestone contained the chocolate chert and reddish radiolarite nodules, highly visible at the field. At first, we record large numbers of flakes, but then a sequence of bifacial pieces where clear retouch appeared. At that point, it became clear that we are not looking at associated finds, but a locality showing consistent Paleolithic technological traits. Several surface snapping areas were recorded, consistent with on-site primary reduction. Diagnostic attributes including level of prepared cores, tools, flakes, retouch plates, and some small to medium bifacial leaf-shaped pieces. Although the material is mixed and lacks stratigraphic control, the main technological traits align with Middle Paleolithic patterns documented elsewhere in Arabia. A small number of items may be related to later traditions, possible Upper Paleolithic or Holocene, Neolithic affinities, but this requires specialist analysis. At the work was a reconnaissance survey, and the specialist lithic analysis has not yet been completed. Several questions remain open. Nonetheless, the sites clearly merit the systematic investigation and hold strong potential for refining the deep time history of Ras Al Khaimah and the wider Emirate. In conclusion, we identified an area with significant potential to year 1 or more Paleolithic site. While the systematic investigation is necessary, the preliminary Qadra assemblage offers a realistic prospect for extending both the geographic and chronological framework of early human presence in UAE. If confirmed, lower elevation plateaus and foothill zones in Ras Al Khaimah could represent important loci or late Pleistocene mobility, tool production, and landscape use. The next section shifts from interpretation to object, from landscape evidence to the artifacts, now entering the museum narrative.
Thank you, Yvette, for showing the first part of our work. So from the field to display. The surveys were completed in 2019 towards the beginning of the global pandemic that led us to the global quarantine. On the 6th of July 2021, the late senior archaeologist Tabor Bulu handed over the stone tools custody from the site survey section directly to me, representing the exhibition section in the National Museum of Ras Al Khaimah. Amid pandemic restrictions, together with Tibor and Anisa, the museum director, who can't be with us today, we started studying the stone tools and grouped them based on their typology. Every artifact were numbered with the field number and stored safely within the form-based grouping that we came up with. The process was completed on the 19th January 2021. 2 days after we finalized the grouping and receiving all the text, illustrations, and reference that he and Yvette prepared, Tabor left us all. May he rest in peace. We continue with developing the text into 2 versions, shorter version to be printed on the wall and the longer version to be provided in digital form in the future. The translation process and design continued, and it was quite challenging to fit everything in such a small room, as you can see. The first group we choose to display includes the cornerstone alongside some stones that were found unfinished or did not undergo retouching. Yvette told us the story of how she and Tibor brought it from the field. Mashallah, it's a heavy stone. For the second group, we sorted by their possible function. For example, the leaf-shaped stone we assumed were used for the same function. We grouped them together. And next to it, we gathered the one-sided retouched stones together. While for the third group, there is a variety of other stone tools awaiting further analysis, so we decided to display them in the showcase drawer. By June 2025, the display setup was completed. We added from our side over the Baluch text. These particular finds were discovered during archaeological surveys led by the late Tabor Baluch in 2019-2022. He identified and selected the most representative samples to become part of his legacy in developing exhibition content specifically for this room. Thank you.
Does anybody have any questions for Yvette or Miriam before we move on?
Does it work? Yeah. Thank you for presenting this assemblage. And it was great to see that you continue working on that and that will find a place in the museum.
I'm not.
Yeah, I understand that. I mean,
only just we try.
Yeah, no problem. In general, I was just wondering, maybe you can tell me where these finds were found. Is that all in the southern part that you indicated at the beginning of your talk, where you had these reddish?
Yeah. That was. Maybe I couldn't able to this is one site. Probably we talked about at the moment of the area. Need a systematic investigation, as I mentioned on the presentation, because has to be divided all of area. What is the merit of the site name and what is probably only just we found one or two pieces. We know very well how could able to named on the site and what is the critical of the name of the site. So we don't know at the moment, but we were surprised when we reach off the plateau and the margin of plateau and the foothill zone. And that was anywhere, believe me, anywhere we found of the real tools. Not just the flakes and probably possibility Paleolithic assemblages or something. No. That was the real tools. So, yeah.
That sounds great. Thank you.
Thank you. Okay.
Thank you very much.
Thank you so much. Thank you.
The next paper in this session will be presented by Suleiman Kim, and she's a PhD student, and so she'll be sharing with us her work on technological variability in the Paleolithic. Thank you.
Good afternoon, everyone. I am Seolmin Kim, PhD student at University Paris 1. For my project, I am working on the late Pleistocene lithic technology of the Arabian Peninsula under the supervision of Hemi Kassar and in collaboration with Keynote Presque. I am very pleased to be here today to present some parts of my research. The study area is located in the central parts of the Emirates of Sharjah. The landscape represents an intact fossil landscape showing various geotopographical characteristics. To the west, there are the sand dunes of the Khibar Desert. To the east, the Mle Ramadan Plain stretches with a number of tributary and wadis developing from the western flanks of the Hajar Mountains. The western edge of the Mle Ramadan Plain is enclosed by the fire anticline. Paleoenvironmental research and excavations reveal that favorable conditions for human occupation have been developed around the fire anticline. The landscape is dominated by limestone formations that contain a rich source for high-quality chert. Regarding water resource, a number of freshwater springs and 2 locations of temporary lake formation have been identified. Fluvial and lacustrine sediment analysis demonstrates that hydrological systems were repeatedly but irregularly and temporarily activated during the late Pleistocene. All these elements attracted prehistoric humans and encouraged them to settle in this area. The earliest occupation is dated to about 210,000 years ago. Recent archaeological research identified that the prehistoric population reoccupied this region by 16,000 years ago. These multiple phases of human occupation, which covered a long period, did not always be linked to humid periods. 3 upper layers show us that human settlement is present during arid phases. New archaeological and ecological behavior should be required in order to adapt to different biogeographical environments and climatic fluctuation. AH2 of fire shelter sequence and AH2 of Buhai's rock shelter are unique lithic materials which allow us to observe the complex settlement dynamics occurring in humid and arid context, and also their cultural evolution on a local scale. Based on the analysis of lithic material, we try to enhance our understanding of this topic. Regarding the methodology applied to this analysis, the lithic assemblage is studied following principle of chaîne opératoire. Reconstruction of diacritical schemes and refitting studies are also conducted for identifying specific reduction strategy. Blank classification based on their technological attributes and their extraction position on the core flaking surface is used to recognize a certain stage of each blank in the reduction sequence. Dimensional comparison between end products and technical byproducts, which are only in complete state, is conducted to examine a degree of core preparation and exploitation. We present first the lithic artifact from age 2 of a fire shelter sequence dated to about 82,000 years ago. They were excavated in trenches 37, 39, and 32, situated about 55 centimeters below surface. Apart from debris, AH2 contains around 1,350 artifacts, including 33 cores. The lithic assemblage is dominated by undifferentiated non-cortical flakes, followed by laminar products and Levallois products. Main objective of laminar production is to obtain a non-convergent blaze using bidirectional reduction of cores with two opposite striking platforms. Despite a very low frequency of cortical blaze, a number of opening blades and semi-cortical blades, both with triangular cross-section, indicate that napping begins on the narrow surface of core and progressively expand to adjacent face. Three refits enhance our understanding of preparation of core flaking surface. Alternatively, using two opposite platforms, wide and elongated flakes and technical blades are removed. During this stage, bladelets also can be produced, but as intercalated products. The majority of these technical laminar byproducts show bidirectional scar pattern with parallel edges. They occupy a large proportion of entire laminar debitage. Combining these observations led us to conclude that the blade core has long sequences with intensive preparation of core flaking surface and specific control of scar ridges to obtain standardized laminar products. These laminar end products are characterized by parallel edges with trapezoidal cross-section, and they have slightly curved profile and faceted platform. After extraction of a blaze, the core volume, especially transversal convexities on flaking surface, are restored by removal of débordant blades. Use of a crest is extremely rare. Only one crested blade was identified. A high frequency of débordant blades ranging in different lengths inform us of a long exploitation of core. Retouched laminar end products are completely absent. However, some of the technical blades are retouched to create denticulate, perforator, or end scraper. Alongside the laminar reduction strategy, Levallois technology was used mainly to produce quadrangular flakes. Production of Levallois points is very few documented. Among 39 Levallois products, only 3 Levallois points are excavated. Dorsal scar pattern visible on complete Levallois products is mainly bidirectional, followed by centripetal and unidirectional. Unidirectional convergent preparation is only observed in the production of Levallois points. The majority of flake cores are overexploited, and some of them are found in fragmented state. Hence, only 2 cores can be classified as Levallois cores. Centripetal recurrent Levallois method and bidirectional preferential Levallois method are illustrated by them. 30 débordant Levallois flakes, mainly non-cortical, are excavated, of which 8 preserved a proportion of the opposite striking platform and present bidirectional skull patterns. These débordant flakes are intentionally overshot, not only to maintain laterodistal convexities, but also to reorganize the removable ridges on the flaking surface. As in the case of laminar products, retouched tools made on Levallois flakes are very few. However, some peculiarity is observed. Levallois flake with a pointed and ogival distal edge are never retouched and directly used as tools. In contrast, some of the Levallois flakes with rounded or transversal rectilinear distal edge are retouched using 2 different techniques. One preferential Levallois flake with centripetal skull pattern has a truncated faceted proximal base, and its laterodistal edges are partially retouched. For non-convergent Levallois flakes edge are modified by abrupt retouch. 2 end scraper and 2 notched tools are made on them. Let's now turn our attention to blue hides. Dated to about 59,000 years ago, AH2 blue hides assemblage shows completely different technological and morphological features in comparison to AH2 juvelphia. Apart from debris, AH2 contains around 770 artifacts, including 53 cores. The lithium assemblage is dominated by non-convergent flakes, followed by triangular flakes and blades. Its core reduction strategies are characterized by simplicity. First, triangular flakes are produced from either single platform cores or multi-platform cores. Unidirectional convergent reduction is mainly used. However, in terms of core volume management, this core reduction strategy is entirely different from a classic Levallois débitage. The cores demonstrate a very limited preparation of striking platforms and flaking surface, and natural volume and morphology pre-existing in the core block are in general employed to produce the blanks. Retouched triangular flakes are absent. Quadrangular flakes are mainly produced from multi-platform cores. Given that the entire surface was exploited, it is not easy to determine the core preparation strategies. However, some single platform cores or multi-platform cores in preparation stage show very limited core volume preparation. Based on volumetric structure and thickness, quadrangular flakes are classified into 3 different blank types: backed flake, thick flake, and oblong flake. Each blank type participates in producing specific tool types. In general, backed retouched flakes are made on the first blank type, burin and notched tools made on the second blank type, and the transversal side scraper or denticulate made on the third blade type. Over half of the quadrangular flakes are retouched, which show a considerable increased frequency of retouched tools in comparison to AH2 juvelphia assemblage. Blade and blade-led reduction system play a secondary role in this assemblage. Very few cortical blades and blade-leds are documented, given that the majority of laminar products are usually found in fragmented state. It is very hard to identify main objective of laminar reduction system. Based on the observations of blade cores and the dorsal skull pattern visible on laminar blanks, They are produced from unidirectional frontal reduction core or facial reduction core. If we now summarize these results, these two assemblages have clearly different objectives. The ultimate objective of Fire H2 assemblage is, without retouching, to obtain a tool which have already a technical characteristic present on its lateral edges. So the desired tool is predetermined since the beginning of the phases of production. To realize it, there is very high control of volume core on flaking surface, removal ridges, and morphology of edges and cross-section. Hence, this is a very natural result that retouched tool made on laminar or Levallois blank or gaz absent. In contrast, the main objective of Bohai's H2 assemblage is to obtain a transformative blank which have a volume and a thickness appropriate to create a specific tool type. Hence, there is no specific core preparation and no certain contour. After obtaining desired blank, technical characteristics are created by retouching. Considerable increased the frequency of retouched tool, diversified tool types, and the complete disappearance of Levallois technology in Bohai's H2 assemblage demonstrates clearly the change in the pursuit of production. Now we are wondering whence comes this change. Is it derived from the new arrival coming from geoculturally different region, or it is just a result of adaptation to environmental fluctuation, or the other factors exist? To answer this question, general observation on the diachronic and synchronic aspects of technological behavior of modern humans are required. Assemblage from late MIS5 are mainly dominated by Levallois technology. There is some difference in core preparation. For instance, centripetal recurrent Levallois method, green bar, is developed in the northwestern parts and the southwestern parts of Arabia. Levallois Nubian method, red bar, is present in the central parts of Arabia and in the Dolfa. This situation indicates large-scale connectivity exchange related to the favorable climatic conditions at that time. However, in Faya, its technomorphological features are completely different from the whole rest of the Arabia. In this region, as we already saw, bidirectional reduction core strategy was used to produce a non-convergent elongated blank. At the beginning of MIS3, linked to arid period, dramatical change is observed. The assemblage from Al-Mahat is still present in the Levallois continuum, but shows shifting preference for pointed Levallois flakes. The blank assemblage from Shibadihia is mainly characterized by the production of pointed blades. Two common points are observed in these two sites. The first is to produce a pointed blank, and the second is a very low frequency of a retouched tool. However, the Bohai's H2 assemblage presents completely different aspects in comparison with them. Bohai's assemblage shows a preference for non-convergent blank and a high frequency of a retouched tool. To conclude, given scarcity of the comparable stratified sites in the Arabian Peninsula, it is still complicated to retrace the settlement dynamic in details and understand the complex cultural patterns. However, some archaeological records from well-dated stratified sites show that there were phases of technological and likely settlement continuity during MIS5, while repeated discontinuity were observed with the regionalism phenomena related to environmental isolation in the records falling into MIS3. Despite assumed hyper-arid conditions, our work in the fire paleolandscape demonstrates human presence in Southeast Arabia during late MIS5 and the early MIS3. This shows that Southeast Arabia had a complex Paleolithic history. We are convinced that this result provides important empirical data for the study of human evolution, in particular for humanity's history in arid context and for the deciphering of humanity's journey from Africa into the rest of the world. Thank you for your attention.
That's very impressive. Looks like a lot of work. Does anybody have any questions for Suleiman? Mark.
Thank you very much. This was very interesting, and of course, it's understandable to be very careful with conclusions regarding continuity or non-continuity of occupation. I do have, I noticed something else that was visible in the photos of the artifacts you showed. It seems like the diversity of the lithic raw material is much higher in Buhais. Did you undertake some investigations into this?
Sir, can you please repeat the last phrase?
Okay, I'm sorry. I noticed that the diversity of the lithic raw material is much higher in Buhais than at Faya. Did you look into whether this is all local raw material or whether there is some provisioning from other places as well?
So I'm so sorry to not very clearly understand your question, but your question is use a raw material block to produce this type, or?
No, the origin of the raw material, because there are many different raw materials. It looks like the diversity is higher at Buhais, and at Faya, it's I know this. It's all the local raw material.
No, it's Buhais and Faya H2. Both assemblage is made on the local raw material, and we can easily find this raw material alongside the Jewel anticline. The difference, maybe it seems like different is because the different degree of patination.
Okay, thank you very much.
Thank you.
Okay, now the last session, the last paper for this session is will be presented by Dr. Ella Egbert, and she's going to present her work in the Western Desert in Iraq. Thank you very much.
Hello, everyone. Thank you very much for being here, and thank you for having me. It's a pleasure and an honor to be part of this session. I will be talking about new lower and middle Paleolithic evidence for human presence in the Western Desert of Iraq. The Western Desert of Iraq is located in the heart of Southwest Asia. It's surrounded by well-studied regions like the Levant, the Zagros Mountains, and of course, the Arabian Peninsula. However, this central spot has not been studied much until now. We, of course, decades of research in the regions around the Iraqi Western Desert have resulted in significant insights into our human history. like early dispersal routes out of Africa, the interaction of human and Pleistocene climate in the influence of Pleistocene climate change on the dispersal of early humans and their routes they could have taken around across Arabia, as well as the identification of the potential interaction zone of Homo sapiens and Neanderthals. So Iraq and the Western Desert is located in this central region, as you can see at a very important spot. However, not much research has been done here until now. Even though previous research has shown the potential, so even already in the 1920s, Field described some Paleolithic material from the Western Desert, as well as in the 90s and the 80s and the 90s, some material has been published. However, due to poor understanding of the geomorphological context and of course, limited descriptions of the typology and technology of the material, these finds remain limitedly integrated in regional narratives on the Paleolithic of the region. I was fortunate enough to be working with Jafar Jothari, and he told me about some Paleolithic material he had discovered in the Western Desert, which instigated this research. So I'm talking today, I should say, about the results from two small pilot projects that we've been doing in the Iraqi Western Desert, which I hope will be the foundation for long-term projects like we've seen elsewhere in the region. The aims of our project are, first of all, to understand the geomorphological history of the Iraqi Western Desert, assess the preservation and distribution of Paleolithic material, and an important part of the project was also to provide training in Paleolithic archaeology and raise awareness about Paleolithic archaeology in Iraq. So far, archaeology in Iraq has been, especially in the south, of course, has been focusing on the rich archaeological record from the Mesopotamian floodplain. So it was important to us to also provide training in Paleolithic archaeology. The approach to survey this huge area, I took a multi-scalar, multi-method approach, starting off with remote sensing and regional landscape survey to understand the geomorphology and the paleo landscape of the region. And then follow on with systematic survey to understand the extent of Paleolithic find spots and obtain a sample for techno and typological analysis of artifacts present. So again, to show you the area, we focused our research in the Najaf province of Iraq in the Western Desert. And this is where that's located. So the landscape of the Iraqi Western Desert it's a stony desert that is characterized by actually not much topography. The main landscape forming process is karstic processes, which of course in itself are evidence for wetter climate conditions in the past. So these landscape forming processes resulted in enclosed depressions in the Iraqi Western Desert. This is important because these are the locations where water has been collecting over the past and still does occasionally. So this map shows standing water over the last decades as is mapped by the authorities, Iraqi authorities. And the photos on the right show that these locations are still quite green and wet from time by time in this desert environment. So obviously these are important locations now and still, and would have been in the past when Pleistocene climate was wetter. And as you all know, targeting or surveying a large area, we have to target our survey to areas that we think are likely to contain Paleolithic material, combining obviously access to water and access to raw material for tools, for the production of lithics and tools. Taking this approach, we surveyed the area around Subica. Subica is one of the main depressions, one of those karstic depressions in the Najaf province, and surveying around this, targeting especially raw material outcrops, so where good flint and chert was outcropping, we identified 20 sites around Subica. And obviously, the locations where the best raw material was present is where we found the largest quantities of artifacts. But you can see that there's actually a lot of potential for Paleolithic material in this research in this region, with 20 find spots, of which we did a systematic survey at 2 locations in the 2 small seasons that we did. First of all, here's Subica 1, that we dubbed Subica 1, is prominence along the Subica depression, where flint and chert outcrops are found, and we systematically surveyed this location to understand the extent of the find spot and understand potential taphonomic processes that influence this, this record. Obviously, it's a palimpsest, like most of the sites we are dealing with in the desert, but the extent of the finds, the systematic survey showed that it didn't move much, as we can find some refitted pieces, as well as a distribution of lower and middle Paleolithic throughout the area. So this is what the material looks like, at least a few examples of it. So we have a lower Paleolithic components, but the majority, like other sites in the region, are of Middle Paleolithic. So we have a lot of cores present and not so much flakes and things. Another location that we analyzed, that we sampled systematically, is what we call Subica 2 and 3. Again, a raw material outcrop. Here we have, apart from lower and middle Paleolithic, an upper Paleolithic presence, which is of course very exciting. So these sites combined show that around Subica we already see, first of all, a rich Paleolithic record and potential temporal differences in landscape use. To put this in context, first of all, the Iraqi Western Desert provides a big potential for contributing to Paleolithic material or Paleolithic research in the region. The huge quantities of material can be analyzed to investigate links with the better studied regions around the Iraqi Western Desert. Like most of the sites, as has been discussed already in this session, these are surface finds, so of course we don't have an idea about the age just yet. Comparing the material with sites in the region that have been dated, for the lower Paleolithic, an age of MIS 9 may be proposed, or any time after that. For the Middle Paleolithic, MIS 7 or 5 seems to be the time frame that we might be dealing with as well here. And a very comparable assemblage has been found in northern Saudi Arabia. So it really fits with this wider record of the region. To sum it up, also in the Iraqi Western Desert, we have challenges, but very important opportunities that can contribute to our Paleolithic research in this region. First of all, we have, of course, the large palimpsest, where deflation causes the exposure of lithics on the surface. Okay, it's a palimpsest, that's a challenge, but the access to large quantities of lithics provides an assemblage that can be studied for techno-typological analysis, and as such can be linked, at least based on typological and technological attributes, to the wider region. On the other hand of the spectrum, we have, of course, areas of deposition where we won't find any artifacts on the surface, but the big opportunity here is that these depressions form a sediment trap, which has a huge potential for paleo-environmental records. In the middle, we have, of course, the area of erosion and deposition, which provides the chance of maybe having some material in context or at least stratified position, and due to erosional processes, this may be accessible. Based on these challenges, we would like to, mainly the opportunities, we of course would like to continue along these ways. So use the rich lithic assemblages from the surface to conduct further lithic analysis. And the scoop of the season that we've just come back from, we have some lithics in stratigraphy. So we will be dating these sediments to at least have an idea. This material may be in secondary context, but at least it is in stratigraphy, so we have some idea of age. And for the future, we would also, of course, target those areas of deposition to obtain paleo-environmental records and hopefully tie in the Iraqi Western Desert also in that way. I would like to thank the Iraqi State Board of Antiquities and Heritage for their support, of course. And these pilot projects were made possible by the British Institute for the Study of Iraq and American Society for Overseas Research, and in collaboration with students and colleagues from Al Qadisiyah University in Iraq. So thank you very much. And
Does anybody have any questions for Dr. Ella? Anybody have any questions for Dr. Ella? No, no, great. I think it's very interesting. There's a lot of potential.
yes,
Yeah.
I hope so. Yeah, I think so.
Okay, so that brings us to the prayer and lunch break. And then the session will continue back in this room at 1:30 or the other rooms, whichever session you're choosing to attend. Thank you very much for being with us this morning. Good afternoon, everybody. Welcome back. Thank you for choosing the Neolithic. We have 3 papers in this session before the afternoon break. We're going to start with Dr. Kevin Lidor, who's talking about his work in Umukoen. Thank you.
Good afternoon, everybody. So today I'm pleased to share with you some updated results of our recent program of research on the Arabian Neolithic in Umukoen. So this project is led by the French Archaeological Mission in the UAE and the Department of Tourism and Archaeology of Umukoen in partnership with the Sorbonne University Abu Dhabi and colleagues from Sorbonne University Paris in France. Let me start with some context. As many of you know, the climate in Arabia in the early Holocene was not as dry as it can be nowadays. Rainfall was stronger and the sea level was higher. This favored tropical coastal ecosystems such as mangroves, coral reefs, and seagrass meadows to develop, and made marine resources very abundant for human communities in the past and nowadays. Coastal communities flourished at that time. Their economies were based mainly on marine resources, obviously, combined with hunting and herding in different proportions according to the different regions. We can recognize several sub-regional Neolithic trajectories, depending on which element of material culture we use to group or separate for these communities. Earlier this year, at the ICANE in Lyon, my colleague Noura Al-Amli from the Department of Culture and Tourism of Abu Dhabi and I proposed the chronology for the coastal Neolithic in the UAE based on our respective recent work on both Abu Dhabi and Umukoen Emirates and combines material culture and paleoclimate data. This allows us to reconstruct a timeline from the mid-7th millennium BC to the end of the 4th millennium. The end of the Neolithic is still poorly known in the UAE and more generally in the Arabian Gulf, especially compared with other areas, especially in Oman. The coastal region of Umukoen is, however, an exception because it preserves clear evidence of human presence in this period. At Umukoen II, the upper part of the shell midden contains 6 deposits of marine shells and traces of houses on wooden posts. These layers come after a phase of strong dune reactivation, as you can see, in the first half of the 5th millennium BC. However, this upper phase is very poor in artifacts, especially in the typical Neolithic artifacts that we found in earlier layers on site, dated to the end of the 6th millennium, that you can see better on the drawing illustration and on the rectified section just at the very, very bottom, not very visible here, because it was done at an earlier stage in the excavation. Those layers from the 6th millennium included a very rich lithic industry with projectile points, very different from the 5th millennium assemblage, but as well Mesopotamian pottery of the Ubaid tradition coming from southern Iraq. These are key markers of the Neolithic in the Arabian Gulf. I also take this opportunity to mention the recent publication of the Umukoen II monograph, just this month. Umukoen II shows a mixed economy that combines fishing, herding, and hunting. I'm not going to develop on that aspect today. Another important nearby late Neolithic site is Umukoen 36. Its lowest stratigraphy also shows thick sand deposits that precede the late Neolithic occupation in the same way as at Umukoen II. Although there are large quantities of faunal remains, artifacts are very rare. Only a few flint flakes, some shell beads, and simple shell tools. This makes it difficult to reconstruct the society in detail. We also have a complete absence of Mesopotamian pottery on this site. The key late Neolithic site in the region of Umukoen is Jag 1, previously known as Akab. It has well-stratified deposits, abundant faunal materials, and substantial quantity of artifacts, plus a variety of structures, including houses and posts, or huts, fireplaces, and even a ceremonial structure. The site was first discovered in the early 90s by a French archaeological team led by Rémy Boucharlat, and then reinvestigated in the 2000 by Vincent Charpentier, then Sophie Méry. The main structure, so the ceremonial structure, is made with the skeletons of dozens of dugongs, a Sirenian marine mammal, and associated with this structure dated from the end of the 4th millennium. There were like thousands of beads and deposits showing the ritual aspect of this structure. In addition to this ceremonial structure, there is a settlement area with 6 deposits of faunal remains and further evidence of houses on post. This occupation has been dated slightly earlier, from the very end of the 5th millennium to the beginning of the 4th millennium BC. The material of this site is very rich, with thousands of beads and other ornaments made from marine shell, some from stone brought from distant regions, probably the Aja mountain. The lithic industry is specialized mainly in the manufacture of these items. Mesopotamian pottery is also present, but very rare. We also see these distinctive cultural traits, such as the production and use of shellfish hooks, which are well known in the late Neolithic in Oman, but hardly documented elsewhere in the UAE, and evidence for a highly specialized pearling industry. In 2004, we began a new series of excavation at JAG 1. Our aims are to refine the chronology of the site to better understand the relationship between the settlement and the ceremonial structure made with dugong bones, and to further explore the overall extent of the site. One of the first objectives of the mission was to review the connection between the settlement and the ceremonial structure, and we discovered that this part of the site has been heavily disturbed by roots and animal burrows, as you can see on the right. And sometimes long time after the occupation, for example, we found many cormorant eggs directly at the surface of the Neolithic layers, with this egg, for example, dated from the early 2nd millennium CE. As well, which was quite a surprise, we identified another major disturbance at the edge of the former location of the dugong structure to the left, you can see on the west, before that happened before its excavation, long time ago. It's a taphonomical phenomenon. This fissure is interpreted as a large gully, probably created by strong erosion on this part of the dune slope. You can see on the topographic model, actually, produced before the excavation, you can't see, but you can see the ditch, the gully. Despite these many disturbances, our recent excavation have exposed a long section that includes the settlement area and the ceremonial structure. This section shows 2 shell-rich layers separated by a relatively thin band of sand. The lower shell layer dates to the last third of the 5th millennium BC, and the upper layer extends the occupation to around 3008, 3700. This seems slightly earlier than the current date for the dugong structure, which is about 3500, 3300. But that date is based on a seagull sample taken in 2009 for the dugong structure, I mean. So we need to obtain new dates. Stratigraphically, the dugong structure lies above these layers, but the deposits are thin and partially merged to the right, to the north. You see the 2 layers are merging and they are very disturbed. Later activity has probably disturbed this earlier layer in this area. So it's also possible that the ceremonial structure was in use for a very quite long time and there were many disturbances of the previous layers. We excavated both shell layers in plan across the settlement and into the transitional area towards the ceremonial zone. We found deposits rich in faunal remains and artifacts, more than 5,000 over the 2 seasons so far, together with fireplaces and postals. Among the finds, we identified many workshops for making shell beads, net sinkers, shellfish hooks, other shell tools. As part of our main objectives, we are also mapping the extent of the site. We have now found evidence of a contemporary occupation more than 100 meters to the southwest on another part of the main dune. The upper layers are also a bit disturbed, but radiocarbon dates point to an occupation at the end of the 5th millennium in line with the dates from the main excavation area. The material culture in this trench is particularly rich. We have evidence for the manufacture of shell beads, a complete chain operatoire for the shellfish hooks, and polished heads as well. This suggests a substantial occupation in this part of the island as well, and therefore a larger Neolithic settlement than previously thought. In terms of animal economy, the assemblage is dominated by shell and fish, as usual for coastal Neolithic site. Some of the fish come from the lagoon, some are coming from the open sea, probably caught from boats using nets and shellfish hooks, including tuna. The shells are mainly clams, murexes, and oysters from intertidal sand and rocky areas. Dugongs or crabs are also exploited, although in smaller quantities. Especially regarding the dugong, the bones are concentrated in the ceremonial structure and very rarely present in the settlement. Terrestrial fauna is rare, but we do see a range of domestic and wild species. This analysis is still ongoing. Now for the finds, the next slides are images, galleries, showing, for example, personal adornment in shell, including spondyle. The assemblage is mainly composed of these adornments in shell and stone, over maybe 4,000, including some shells that are probably brought from other regions, like the Engina mendicaria, which are known from different localities in Oman. Other type of adornments, including earring in, that's not a fish hook, it's an earring in mother of pearl, maybe some other earring or ring, pendant, the cylinder beads of the ACAP type with the perforation at right angle at both ends in shell, but also their typologically like brother and sisters in stone, in soft stone, other kind of small adornment in stone as well. Complete chain operatoire for the shellfish hooks, and also quite good quantity of pearls, which is something that can be highlighted for this site because given the pearls found in the past, already in the previous excavation, we reached a total number of maybe about 23 or 25 pearls already for this site in a small excavated area for a coastal site where we have exploitation of pearl oysters, which seems to highlight a very dynamic and important pearling activities since the end of the Neolithic in Omalcoain until the more recent period. Different type of shell tools or shell containers. Lithic industry very, very limited. We have a few diagnostic pieces like the tile knife in tabula flint or shirt. We have as well a lot of splintered pieces and small flakes that has been reused as borers for the manufacture of shell beads. The total amount is probably a lot, but we don't have an idea exactly of the total amount of lithic because we are collecting all the material from the sieve, and we need to sort everything, but we probably have thousands of these small lithic pieces. But much work needs to be done on sorting the material. And also some polished aces, including a nice one in hematite found in the small trench we opened on the other side of the dune. Some ground stone, like pestles or hammerstone, some net sinkers as well. and Mesopotamian pottery, very rare, attested only in the earlier layers of the site, not on the layers from the 4th millennium, only layers from the end of the 5th millennium. But more detailed presentation will be done by my colleague Charlotte, just not the presentation after, but just after. To conclude, so now we have a better understanding of the extent of the site, which seems to be way more extended than we were previously thinking, and possibly some areas with better preserved stratigraphy as well, but we need to further work on that. We are still hoping to find the funds to do a GPR survey on the site, actually, to have a better idea as well of the variety and the repartition of potential structures, including maybe graveyards, other housing areas, maybe as well another ceremonial structure made in Dugong, so let's see in the future. So for the following season, we are in terms of opening trenches without planning to do the GPR for the moment, but if we do the GPR, we're going to adapt our strategy, but we are planning to further extend the excavation in the area C, where we already found evidence of presence from the end of the 4th millennium. Document, maybe we're going to try to open a bit on the east of the main excavated area to try to catch some less disturbed areas for the stratigraphy of the 4th millennium, because we might have some areas that are less eroded over there. And as well, we're going to open a new excavation area in area B, where there was already a previous test trench done by Vincent Charpentier in the early 2000, which has showed that there are layers at the very, very bottom of the stratigraphy dated from the first half of the 5th millennium. So thank you for your attention. Yes.
Thank you, Kevin. I really enjoyed the talk and the update of the results from ACAB. I was particularly interested, I know you said you're still working through sorting the lithics, but if you've noticed any particular pattern for either of those surfaces that you have seen associated to the ceremonial structure.
Regarding the lithic, in the ceremonial structure, it has been published, there's one tile knife. And apart from that, I think that's it. The problem with the material associated with the structure, we know something regarding that. We know that there's a very huge concentration of adornment from the structure because it's way more than all around, and there's very particular types of adornments associated with the structure. So that's really associated with the structure, particularly the elongated bits. Regarding the other things associated with the structure, it's a bit doubtful because the structure is itself built on previous layers directly at the surface. So everything associated to the structure in terms of artifacts can be just from the occupational layers. So including the tile knife. So it's a bit, there's some doubts about that.
Any other questions? Thank you very much. Next we have Dr. Abby Buffington, who's presenting social revolution in the Arabian Neolithic. Thank you very much.
This is Abigail, yes.
Good afternoon. I just want to say, firstly, thank you to the organizers for including our paper at this historic seminar, the first located in Arabia, and just to share my impressed state with this beautiful museum. So this paper is a bit of a departure from what we've heard in the session so far. These excellent papers talking about updates to data collected in recent fieldwork and legacy data as well. This paper is mainly a conceptual study that we are hoping, my co-author Joy McCorson and myself, who unfortunately couldn't be with us today, that we are hoping to seek your collaboration and interest in expanding this idea, this hypothesis that we want to present to you today, and really building the framework theoretically for this hypothesis and utilizing a couple of case studies based on multiple previous studies that we have engaged and presented in terms of whether it's applicable to those cases and to expand to thinking about it more generally in synthesizing the Neolithic. So this idea of the Neolithic as a revolution is one that has some history within archaeology, particularly associated with figures like V. Gordon Childe, in this idea of a Neolithic in which mastery advanced over plant and animal resources and a singular pathway to dependence on these managed resources, and some expectation of significant ascetism. The assumptions underlying this concept have all been challenged by primary archaeological records, wherein agriculture is adopted in a multitude of pathways, cultivation, both localized, domestication, adoption of domesticates from elsewhere. They're lengthy or attenuated, or in some cases interrupted, and they are adopted as systems or developed locally by local communities. The argument hinges on a view of food producing as possessing a potential of ever-increasing production under progressively greater land development and increasing sowing and increased labor from domestic reproduction as a contrast to foraging economies. In this case, labor was considered of a minor consequence in comparison to other economic systems. The mastery narrative expressed in this angle is one that's reverberated in other theories, explaining, for example, in some cases, megalithic structure, construction at places like Göbekli Tepe, in contrast to mutualism and interlinked relations between humans and species that fall under domestication. And instead of archaeological records of the PPNA, like Jorf al-Amar that you see here on the site, and Göbekli Tepe itself, suggest an investment in sociality of collective construction, in ceremonialism, and in these cases, a subsequent destruction, in which economic practices play an integrated role. Though these identifiable economic activities, traces, certainly cannot be divorced from political dynamics of the community. And our approach within this paper is rooted in historical materialism, wherein a dialectic of social meaning is embedded in relationships between people and their environment, with task sequences fitting into the social realm. We built on previous work, particularly of my co-author, on the development of the unit of the tribe as emergent from Neolithic pastoral economies into later periods, who mobilized units to build later small-scale stone monuments. Pastoral communities based on comparative study of contemporary herders are at risk of catastrophic loss to the basis of their sociality, their herds, particularly of key animals. This stochasticity results in long-term development of potentially inequality among herders, wherein those who persist without a self-sufficiency quantity are likely to become dependent on herders who have herds beyond this self-sufficiency level. Herders to herd owners, sorry. The idea of disentangling craft and technology into processes of production and distribution and consumption and ultimately disposal is one supported by a long history of chain operatoire, and you've heard multiple colleagues of mine discussing its use in their studies as well today in archaeology. The concept was coined by Leroy Goran, and within the same project Ethnologie, Magat was already applying a version to agricultural production. Objects and practice require skills, mental procedures, tools, raw materials, and social relationships to be formed with particular pathways. The lithicists who first used the method to define the sequences of constructing a tool or a core are immortalized in the classic case of the Levallois. Thank you. Lemonnier added the variable to technical skills of a craft group due to the pronounced use of ethnography. Well, there certainly is utility to using a chain operatoire model to study systems of food production. Agricultural systems are cyclical, and this particularly relates to procurement, which certainly could be episodic in the case of adopting later domesticates, but the procurement itself becomes internal to the process itself. Strand, who you see a table from here, provides an example of such a model integrating archaeobotanical and zooarchaeological remains into the data set for producing sequences of gestures in textile making. Worth a mention here is the potential for seed or breed, in the case of animals, sharing among food producers. And we know historic and antique farmers sought to regularly share seeds in field-based agriculture, maintaining a certain level of biodiversity. Key to our study is the integration of labor mobilization. Ancient Hawaii has been used as a case study for these types of models due to the rich ethno-historic records. And Kolb, who you see a table drawn from his work here, takes on the case of Wahuli with an emphasis on architectural energetics. And the use of the social unit in this case is the community. And community is defined as a locally bound multitude type of sites. And in fact, he uses the term ahu pua, which eventually becomes the unit of producing a tribute during the expansion period. And he defines the family or the household as small scale, absent in displays of differentiation and status, with only minor compensation within the kin group. And contrast this on the opposite side of the scale with corvée labor, which is large scale, symbolic, elite recruiting, and centrally organized and obligatory. So pioneering in paleoethnobotany is the work of Gordon Hillman and also Glynis Jones at a similar time in Greece, a method to interpret assemblages of plant remains. This work was based on ethnography conducted in Asvan in eastern Anatolia, where Hillman argued that there was a persistence of 19th century developed technologies in farming. Crop processing could occur on domestic or communal basis due to the presence of threshing floors that could be utilized by multiple households. There were 30 noted operations, a term well suited to a chaîne opératoire approach, and he accounted for fragmentation with the use of the most durable secondary components for ratios, suggested that mixing of variable operations, while always a potential, would represent a minor set of cases. Hillman also noted a potential lag in practices reflecting migration from populations, and he referred to this in the case of storage on the spikelet being something that communities in arid environments would utilize to retain the moisture of the grains, that would persist when communities move to wetter environments. He called this a cultural intrusion. Oh, I didn't actually show you that page, sorry. In the case of Arabian archaeology, household archaeology's potential is more limited, where domestic contexts are more limited in their presence in sites. Recovery of macro remains has been challenged historically in the region, where mud brick impressions or ceramic impressions can be a significant source of information on presence or absence of particular species. A multi-proxy approach drawing on sedimentology, sediment analysis, microfossils, and micromorphology may provide a way to account for these limits and gaps. Harvey and Fuller used a multi-proxy approach with macro remains and micro remains to study the crop processing procedures and assemblage for rice and millet remains in India. The authors noted the gap associated with carbonization as the main preservation for macro remains, that light fragments and fragile structures would be less likely to be recovered and therefore would impact interpretations of particular contexts representing certain task sequences. Gross, Balthazar, and colleagues have previously published in 2017 on the observation of wild date palm in the flora of Oman's Hajar Mountains. They highlighted the key role that ethnobotany plays in understanding plant biodiversity patterns in augmentation of genetic records, of which date is known to have a fairly complicated genome. Traditional ecological knowledge, or TEK, is a domain of knowledge that's recognized deriving from traditional local communities in addition to those of indigenous communities in terms of testimony and an intangible and tangible heritage. You see examples here of date palm cultivating in a community, in a different environment, a different place, but also a dry land, much like Arabia, here in Baja, Mexico. So this brings us to our research objectives. Can pastoralists be conceptualized as possessing task sequences? What are the task sequences we can identify in date palm farming? What are the archaeological indicators of oasis cultivation? And is there mirrored processes of task sequences which indicate a growing interdependence? Despite Neolithicization, lengthy theoretical history as an economic revolution, there is now evidence, as we stated, for profound social development marking its beginnings. First and unequivocally, the introduction of domesticated animals, sheep, goat, and cattle into new regions marked a transformation in people's access to resources. From preying on wild animals, herders shifted to protecting them, deferring the harvest of their investments, and in managing environments. Archaeology detects these deferments through zooarchaeology, cull patterns, taxa, and through lithic technologies and through monuments, including knowledge, allies, water, and graze. The earliest monuments in southern Arabia coincide with specialized pastoralism as practiced at Wadi Sana, where the Hashia cattle skull ring in ritual form marks the convergence of multiple herds. At contemporary Jebel Buhais in eastern Arabia, mobile cattle herders return to a common burying ground. And emerging from research of mustatils in northwestern Arabia, perhaps a similar premise of monumentality and its socio-ritual purposes is associated to mobile cattle and caprine herders. To our knowledge, the labor metrics that have been identified in the case of South Arabia's small-scale monument constructors has not been analyzed for Northern Arabia's Neolithic mustatils. Dating is roughly to the same period. Based partly on interpretations, excavators attribute to mustatils a comparable socio-ritual role in Neolithic herder populations. Published dimensions and details of construction techniques suggest that the mustatils represent a large stone volume. Using a crude estimate from the description and summary statistics of 97 mustatils, we suggest that they have an average stone volume of 262 meters cubed. The labor involved greatly exceeded the labor estimated for stone platforms in Dhofar, which are estimated at an average volume of 22.7. It's also apparent that some of the uprights in the end platforms of mustatils exceeded the length of the slab that a few men in one herding household could feasibly carry. And therefore, by the same stone length threshold used to establish multiple participating households. In Dhofar Neolithic platform monument construction, the mustatils or significant segments thereof also were constructed by a simultaneous labor force. In highlighting Neolithic task sequences of the late 6th to 5th millennium, we also note that the archaeological record offers no clear evidence of integrated, interdependent, specialized tasks. The idea being, as herders move to supply their animals with graze, they move these stone resources with them. There is an argument to be made for a transition from individual specialized prowess to collective production during the 6th to the 5th. It appears with socioeconomic complexity as integrated, interdependent, specialized tasks later in the oasis socioeconomic systems, the emergence of which can be understood as further social resilience or reorganizing. Cultivation has a shorter history in Arabia in comparison to animal husbandry. Part of the challenge of agriculture is the necessity of irrigation for propagation. The history of the afflage and Keynote technology is not suspected to persist to the earliest oasis farming, but there is evidence of smaller scale water management dating to the Neolithic. Where macro-botanical remains are recovered, including impressions from ceramic and mud brick, date remains suggest evidence of its cultivation becoming a more common component of assemblages as early as the Bronze Age, the late 4th millennium. And there are dates to around that period associated with seal impressions from Mesopotamia that suggest hand pollinating was evident in these communities. Both have within the areas evidence of previous gathering of wild dates, and so that evidence seems to precede oasis farming. The date palm figures heavily into the economic, social, and religious lives of the people who inhabit the Omani and Emirati and eastern Saudi oases. And this is partially explained by the perfect fit of the tree into the environment of the region. You can see that date palms require a hot environment, but a high water table. And all the named types are likely produced via asexual reproduction, use of suckers, and 90 to 95% of the oasis plantation represents female individuals, with seedlings only rarely spared. The tree reaches a height of 25 meters and 40 to 50 centimeters in diameter and is defined by leaf scars. And these leaf scars are the result of every year pruning up to less than 3 meters into the core of the tree. Not until 15 years is it breached. So I just want to present here the expected task sequences of operations we may see in date palm cultivation from observations of small-scale producers in the case of Oman. A year is expected for the cultivation cycle from the initial pre-irrigating to the irrigation following harvesting until the subsequent pollinating. And this first set of procedures is what we would label planting. You can see this relates to management. And then to harvesting and distribution. Just as a note, date palm serves as an important node in sociality. We know even in countries where date is a primary crop, like Oman, is actually not a primary export. So it mostly serves a role within the domestic, the supra-domestic, and for animals as well in terms of fodder. And the last phase of this cultivation sequence, we would expect the integration of other crops within the ground cover of date palms that had matured. And here is my attempt to define some correlates in various proxies that can be revealing about task sequences. I also attempted to theorize about labor needed to mobilize for these steps. Directed ethnography is needed to provide numbers of individuals required. The mobilized labor also associates the social resource networks, such as task sequence 2, which requires a large set of stakeholders and intermediaries. In the later phases, fodder use distribution is expected to yield a higher microfossil density. So just as a last point, the questions that we want to pose, how we would answer them. So the social unit of tribes likely provided the baseline for early irrigation scheduling, cooperation, and other labor cooperations that were essential to date palm agriculture. And the palm cultivation as a dominant crop produced in the region of Southeast Arabia, and a more minor component in other landscapes, with a likely maximum export market representing a small minority of the production, demonstrating a significant value for domestic and inter-community use. Thank you.
A lot of, this is not a pan fruit for discussion, but we don't have time for questions, but we will be having a coffee break after this last paper, so discussion can continue then. Next we have, as Kevin alluded to earlier, Charlotte Damiano, who will be presenting some work on ceramics in the Neolithic. Thank you.
Thank you. Thank you. Ladies and gentlemen of the committee, dear colleagues, good afternoon. First of all, I would like to thank the committee for giving me the opportunity to present here a part of my research. My name is Charlotte Damiano, and I'm currently pursuing a PhD at Sorbonne University under the supervision of Professor Benjamin Mutin and Dr. Johnny Baldi, researcher at the CNRS in Lyon. My research focuses on the Ubaid period, and more specifically on the interactions between southern Mesopotamia and the Gulf, particularly the United Arab Emirates, through the study of ceramics. My colleague Kevin Lidour just introduced some elements about chronological period and sites discussed, so I won't repeat what he said, but I will focus on the ceramic studies. Pottery is indeed the most characteristic artifact of the Ubaid period. By re-examining these ceramics, the aim of my thesis is to refine our understanding of the mechanisms behind the circulation of Ubaid productions, as well as the processes that enabled their diffusion from Mesopotamia toward the Southern Gulf. The aim of my presentation will be twofold. First, to provide a state-of-the-art overview of the Ubaid in the Gulf, based on material recently excavated in the Emirates, and second, to present the methodology I apply in my study to ultimately propose a revised chronology for the early Ubaid in this region. The Ubaid period corresponds to the last fully village-based phase of southern Mesopotamia. Defined in the 1920s, the term Ubaid now refers to as a site, a chronological period, an archaeological culture, and a ceramic style. Between the 1960s and the 1990s, this period was subdivided into 6 phases, but this sequence is now being reversed thanks to new data. Phases 0, 2, and 5 in particular have been questioned. Recent research indicates that Ubaid 0 was likely not part of the Ubaid sequence, and that Ubaid 2 may represent a regional style more than a true phase. In the classical model, the Ubaid begins and develops in southern Mesopotamia, phases 0 to 2, before expanding from phase 3 onward. Phase 4 would represent the maximum extent of this expansion, followed by a contraction in phase 5, which precedes the Uruk period. What you see here corresponds to what is commonly referred to as the Ubaid horizon, the expansion of Ubaid material, and particularly black on buff pottery, notably into Iran. The expansion toward northern Mesopotamia is very well documented, as is its presence in Iran. By contrast, expansion toward the southern Gulf is much more discrete, and the archaeological data are considerably more fragmentary. The southern Gulf follows dynamics very different from those of the north. The northern Gulf is naturally better connected to southern Mesopotamia, which explains the significant quantities of Ubaid artifacts found at As-Sabiya or Bara. In the south, contacts appear more discrete and sporadic, and likely indirect, and therefore require particularly fine analysis. The presence of Ubaid material in the Gulf was identified in the 1970s, confirming a genuine expansion of Ubaid culture toward the south. Several sites in Kuwait and Saudi Arabia have yielded Ubaid ceramics, and in the Emirates, Ubaid pottery has been attested since 1988, notably at the site of Al-Quwain 69, which no longer exists today. Several researchers contributed to the establishment of this corpus, for example, Carter in Kuwait at As-Sabiya, Masri in Saudi Arabia, and from 1999 onward, the French Archaeological Mission in the Emirates. In the 2000s, Sophie Méry assembled a substantial Neolithic corpus from the Emirates, notably at Al-Quwain within the French mission, as well as at Delma and Marawa, in collaboration with the Abu Dhabi Island Archaeological Survey, or the ADIAS program. So it is within this context that the Marawa vessel, which is presented in the exhibition nearby, was published in 2005. According to a convergence of expert opinions, this vessel clearly belongs to Ubaid I. Yet, until then, Ubaid I was thought to be restricted only in southern Mesopotamia, so fully in line with the classical model in which expansions begin only from Ubaid III onward. So the identification of a Ubaid I vessel in the Gulf, therefore, demonstrates the existence of very early, albeit tenuous, contacts. It challenges the idea that diffusion began only in Ubaid III. So already in Ubaid I, exchanges existed, supported by logistical or social mechanisms that remain to be characterized. So over the past 20 years, however, the Southern Gulf has received less attention, while Polish teams have continued their work in Kuwait. The current moment is thus particularly favorable for reassessing the corpus, integrating new data, and reconsidering the question of the Ubaid in the Southern Gulf. Last April, I joined the French archaeological mission in Al-Quwain at the site of Jazirat al-Gala, directed by Dr. Kevin Lidour, in partnership with Sorbonne University Abu Dhabi and the Department of Tourism and Archaeology of Al-Quwain. I also took part in the most recent excavations in Marawa 11 with the Department of Culture and Tourism of Abu Dhabi alongside Noura Al-Ameli. This field represents a decisive stage for my PhD. It enabled me to assemble a significant portion of my ceramic corpus while also illustrating the dynamism of current archaeological research in the Emirates. This work is also part of a broader network, including teams active in southern Mesopotamia, notably those of Johnny Baldi and Régis Vallet at Ouaili. The broader objective is to establish a refined chronology of the early Ubaid in the Southern Gulf, based on a robust corpus and detailed ceramic analysis. To date, my corpus comprises 31960 sherds from two main groups. The first group comes from Mesopotamian and Iranian collections: Eridu, Ras Alamia, Tel al-Ubaid, Uwaili, Susa, and Tepesialk. These sets, often published but not always, constitute essential references. They currently represent nearly 1/4 of my corpus. I studied them at the British Museum and in the Tessonnier of Paris 1 Panthéon-Sorbonne University with the assistance of François Gillini and Hugo Nakero. The second group comprises more recent collections from excavation conducted in the Emirates: Jazirat al-Gala, Delma, Marawa 11, Bainuna, Khaha, Al Kuwain 2, and Al Kuwain 38. This material now represents more than 3/4 of my corpus, and some of the sherds were discovered only 2 weeks ago, again demonstrating the dynamisms of ongoing research. Kevin Lidour and Noura Alameli assist me in recovering sherds from Emirati surveys and excavations. Ceramic analysis relies on a rigorous methodology, beginning with macroscopic observations, measurements, identification of clay and paint colors using the Munsell code, and examination of surfaces. Then I conduct systematic microscopic observations of the sherds using a dynolite microscope in order to identify textures and inclusions. This step allows for a first classification of fabrics from the finest to the coarsest. Then I develop a typology based on a systematic series of photographs and drawings applied to both groups of the corpus. The analysis then continues with structural and physicochemical investigations made possible by the facilities of Sorbonne University Abu Dhabi and the laboratory of New York University Abu Dhabi. They include 3D microscopy and CT scanning. These are conducted by Dr. Horaib Al-Ketan, head of the Advanced Manufacturing Core facility at New York University Abu Dhabi, together with Delphine Civilet, associate professor at Sorbonne University Abu Dhabi. On screen, you can see, it's supposed to be a video, but it doesn't work. So on screen, you can see an example of a sherd scanned by CT. So this photo shows in green the porosities and in red the heavy mineral inclusions within the ceramic fabric. It is particularly clear that on one surface of the sherd, heavy inclusions cover the exterior, and this corresponds to the painted surface. The quantities of voids and inclusions expressed as percentages are then processed statistically. This method is especially valuable because it links the classification obtained from dynolite and 3D microscopy based on fabric fineness and inclusion size to the quantitative data produced by CT scanning. The physicochemical analysis therefore serves to confirm, refine, or challenge the initial observations to identify recurrent fabric recipes and to statistically process the entire dataset. Then I undertook a series of more advanced analyses, still by the labs of Sorbonne University Abu Dhabi and conducted by Delphine Civilet. So SAMED for atomic characterization, X-ray diffraction for mineralogical structure, X-ray fluorescence for heavy elements, and LIBS for broad spectrum analysis. So here you see a SAMED's image of a sample. The black areas correspond to porosities and the white areas to dense inclusions. Approximately 90 spots analyses are conducted on this single image, including both inclusions and matrix. So far, around 10 sherds have undergone this in-depth analysis, The results are still very preliminary and more samples will need to be studied to confirm the emerging trends. Nonetheless, this approach already makes it possible to develop an innovative statistical methodology. At this stage, 6 distinct chemical groups can be identified, so 6 recurrent compositional recipes. This classification must, however, be handled with much caution. Analyses are ongoing and the dataset remains incomplete. Further analysis will be necessary to clarify technological traditions or workshop origins in order to better understand the provenance of the ceramics and their circulation routes. Similarly, pigment analysis on painted sherds still need to be conducted on a larger corpus before reaching robust conclusions. And in addition to compositional and structural analysis, contextual and field data must also be taken into account, together with the various radiocarbon dates obtained both in the past and recently. So it is in fact the radiocarbon data that allows to assert several points. With the radiocarbon date from the context of the Marawa vessel, it would date to around 5600 BCE, pushing back the presence of Ubaid material to at least this period. The significant presence of Ubaid ceramics at Delma between 52 and 4600 BCE show that at this time contacts were active and well established. At Al Quwain II, Ubaid material is also attested between the late 6th and early 5th millennia, though with a much more marginal presence in layers of the late 5th millennium. And the same is true at Jazirat al-Gala, whose main occupation dates to 43-3700 BCE. Ubaid pottery is very scarce there, as said Kevin earlier. And the Ubaid pottery only appears in the earliest layers around 43-4000 BCE. It mostly consists of late ceramics close to the Ubaid-Uruk transition. Across these sites, a clear decline can be observed in the amount of imported pottery, or in the frequency of contacts, particularly during the 5th millennium. So the analysis currently underway are already yielding tangible results, such as the identification of 6 recurrent chemical groups, and above all, the methodology that enables these results appears very promising. Of course, these results must still be strengthened, as the data currently derive from a limited number of samples. Yet, they open a solid path for characterizing recipes, technological traditions, and ultimately circulation networks in the region. The next step will consist in expanding this analysis, particularly on a larger corpus and on pigments, and refining the typology based on the material now under study. This work will not only allow for the establishment of a more precise chronology of the early Ubaid in the Gulf, but also contribute to a better understanding of the intensity, the nature, or the modalities of contacts between southern Mesopotamia and the communities of the southern Gulf during the Neolithic. Thank you very much for your attention.
Does anybody have any questions for Charlotte? There's one here. Do you have the microphone? And one up there. We're just getting a microphone.
Yeah, thank you for your presentation. In your revised chronology of the Ubaid period,
yep.
Where you put together Ubaid 1 and I think Ubaid 2 Haji Muhammad, you said that Ubaid 0, which is only found at Tel al-Waili, I think, in
yes.
southern Iraq near Larsa, is not Ubaid at all. So what made you revise this classification, which seemed to be quite unanimous, I think, in the 80s and 90s, under the studies of Jean-Daniel Forest's team at Tel al-Waili?
The classification is quite ancient, And it's just actually discussing with Johnny Baldi, who is currently working in Uwaili, who thinks that the Ubaid Zero is more a late phase of the Neolithic previously than the Ubaid period. I don't know if I answer your question. I don't know. We can discuss later.
Thank you very much for your presentation. Just I have a quick question about the carbon dating for your pottery shards. Just I'm asking what exactly is the element you date from the pottery since it's inorganic material?
I'm sorry, I did not understand.
You talk about the carbon dating for the pottery shards or pottery fragments you have.
No, actually the carbon has not been conducted on shards, but on the context that accompany the shards. As far as I know, the pottery that we find in the UAE is not made by organic inclusions. So it cannot be conducted on shards, but just on the context around the shards.
Okay, thank you.
You're welcome.
Hi, thank you for your talk. Sort of following up on the first question, you present that one vessel from Marwa and say it resembles Ubaid 1, but that doesn't fit the chronology, or it sort of pushes it way earlier. Isn't there a chance for, shouldn't we consider heirloom vessels or just the circulation of vessels long after they were produced?
It's a good question, but actually many experts have seen the Marwa pottery, and it really, for them actually, it was 100% sure or something that this pottery was in fact Ubaid 1. So I agree, because it's a very scarce proof of early Ubaid in the Gulf, but I can only transmit what we discussed about.
Okay, yeah, but the vessel could still be moving around after it was produced, so thank you.
Yeah, thank you for a great talk. I am the person who found the Marawa pot actually and excavated it. And just to clarify the dating is done on charcoal on the layers immediately above and below the vase. So we have a kind of bracket date between, I think it's 5,500 to 5,800. And it falls somewhere in that. But I just wanted to add one thing. I think we still have an additional Ubaid sherd that you could include in your research from Al Ariam. You didn't have this point. You had it? You had it? Okay, it just wasn't on the map. I couldn't see it, but yeah, because you have the one that you found, Kevin, Baynuna, one, whatever. But yeah, no, it's good because that's an interesting sherd. It looks like it might be an early one as well. It has some dots on it, so similar.
Yeah, so it's still in discussion.
Anyway, I'm so happy that you're doing more work, because we found the Marawa vase in 2004, and 21 years later, and now I'm really happy that you're doing your research, and look forward to hearing more results. And thank you, and keep up the good work.
Thank you very much. And thanks for answering the other questions.
Thank you very much. We're now going to have a short coffee break outside, and please be in the room you'd like to spend the afternoon in by 3:20. Thank you.
focusing on science and technology. So I hope we're going to get a few more people into the audience when they hear us talking. So please come in, be welcome, and get seated. And as a first speaker, I would like to introduce Susanne Lindauer, who will speak on radiocarbon dating of shells and charcoal at Schimmel, Ras Al Khaimah. Please, the stage is yours.
Yeah. Thank you for having me. Can you hear me well? Is that okay? Give me a wave when I move away from the microphone, because usually I run around and have lots of gestures, and now I have to behave somehow. Thanks for having me. My talk might be slightly different for you because I'm a physicist and a dating specialist for radiocarbon and luminescence dating methods, but I take every chance to work on shells and charcoal and play around a little bit, as we physicists usually do. First, the sites where I will be talking about. Schimmel in the north will be the main site, where I was kindly invited by Lloyd Weeks, who will also give a talk about Schimmel. And I will compare the data I received with Tel Abrak in the west and Kalba on the Gulf of Oman coast. Why would anybody want to do radiocarbon on shells? I mean, many people tried when they found some shells during an excavation, and then they noticed, ooh, that doesn't fit. It seems to be a little bit too old. Yeah, that's not surprising, because shells live in the ocean, and the ocean, maybe you have heard about the conveyor belt. So we have areas of upwelling and we have areas of downwelling, and when the fresh carbon from, I didn't press that. Okay. When the water is going down to the deep sea, it takes with it the carbon from the atmosphere, and it can travel there for about 1,500 years. Well, radiocarbon has a half-life of 5,700 years, so when it travels for over 1,000 years, a really significant amount of it has decayed when it, somewhere on the other side of the planet, comes back to the surface. Of course, the organisms like fish and shells or corals, as we can see, they, of course, live in that area, and they incorporate it because they don't know that it's depleted in radiocarbon, and I think they wouldn't mind. But that's the reason why we have shells that seem to be older than they should be. I like that because it's a bit difficult, so when there are problems, you learn most about things, and we can get hold of this so-called reservoir effect by pairing data with terrestrial data, so like charcoals here in the area mostly, because there's not much preserved in arid environments, so no textiles, no hair. If we have bones, so we don't have collagen, so this is a challenging area, but we find the shells along the coastlines in very abundant shell middens, so I think it's important to give it a go. What I should also notice is, of course, there is a marine calibration curve. I plotted it. It's the green one compared to the atmospheric calibration curve. And you see it's systematically shifted. This marine calibration curve is a mean value over all the oceans across the Earth. But of course, as I said, we have areas of downwelling and we have areas of upwelling. So of course, it will be different in these areas. So we have to determine a local marine reservoir effect. And it can be negative or it can be positive. If it's negative, it is closer to the atmospheric curve, and if it's positive, it's further away. But shells do not only cause problems in dating, they give us a lot of information as well. They grow like tree rings, and we can also take these for readings. You will see that in a minute. The shells I'm concentrating on are the ones I see most abundant in the excavations. That's on the left, Terebralia palustris, and the two bivalve species, Marcia, in various subspecies, and Anadara. Not only Uropygimelana, but also the other ones. The bivalves are very nice because they bury in the sea, in the sand. They're in the intertidal zone. They feed on algae and foraminifera, etc. So they have a purely marine radiocarbon signature. Terebralia we find very often, but of course it causes some problems. It feeds on leaf litter from mangroves. Actually, it's specialized on this. But mangroves, although their feet are in the sea, they do the photosynthesis with the atmospheric carbon. So mangrove leaves have atmospheric signal, their feet don't. So Terebralia has a mixed signature, which is half marine, half terrestrial. Maybe there are also, like we have vegetarians and we have people concentrating on meat, maybe shells have similar effects. So everybody said, oh, don't do Terebralia, it's so complicated. But I said, well, it's found everywhere, we have to tackle this problem. So the first results from Shimal. Actually, I have samples from 3 trenches, but I thought if I put all 3 on the screen, you cannot recognize anything. Usually when I sit in a trench like a child in a gift shop, I collect from the bottom to the top, and I look for charcoals and shells physically in contact, because if I find a shell here and the charcoal 2 meters away, it's not the same layer, even if it looks like this. I cannot guarantee that they were contemporaneous. I also cannot guarantee it when I find them physically attached, but at least they were physically attached and the chances are higher. So that's why we have in Trench B, that's the one you saw on the map, we have a large data set for one phase, because when I go to the field, I don't see that this is a phase. I collect from bottom to top, and then later, trying to model the charcoals first without the shells, I find out about layers, getting in touch with my archaeologist who helps me interpret the data, and so we then look for the depth or the elevation. And if this is still not a bit ambiguous, then we look for the archaeological phases like findings of pottery, etc. And that nicely arranged and allowed us to model 3 phases for Trench B. The laser pointer is a bit weak. On the ceiling it's bright. But on top you see there is only 1 data point for charcoal and 1 data point for shell. This is of course statistically a bit vague. But nevertheless, I wanted to plot it all to give you all the data. In Trench A, we also see that you can always recognize the shell data because it's much broader and the model makes it fit better, so it then looks smaller. In the bottom of Trench A, which is actually the top, I was just stupid to plot it in the right way. You see there is a charcoal outlier and a shell outlier. I noticed that people usually drop this data. I did not include it in the model, but I would always give the data because you never know what you can learn from it. It can be pointing to, when you look, the charcoal seems to be correlated to the one on top. So maybe through some circumstances, it is contemporaneous to the charcoal, which actually was found 1.50 meters deeper. Maybe a child was taking the shell 2,000 years ago, carrying it away and then throwing it. You never know what happens. So sometimes from these outliers, you learn more than from the whole stratigraphy. So don't ignore data, always present it. The future generation will find out what happened. When I calculate the reservoir effect, according to the phase, I put arrows where we only have statistically weak data, like 1 charcoal and 2 shells, or 1 charcoal, 1 shell, or where there's not several specimens of charcoal and shell. Nevertheless, they somehow fit. You can also see from the arrows that these have the largest arrows. The nice Trench B data set with wonderful many charcoals and shells has the smallest error. And Lloyd, we have a gap, we have to close that because it's in a really interesting part. It seems that the reservoir effect starts smoothly and then becomes chaotic somehow. And I would like to solve this. There is a gap, we don't know what happens in this gap. I guess it is still chaotic, but of course I cannot know. So this is the data as we have it so far. and we have to check why this is the case. If we compare it to Tel Abrak and Kalba, I should point out that Kalba and Tel Abrak are on the left, the blue and green data points, and these are not in CalBC, these are uncalibrated. But you can see the clearer pattern. In fact, they overlap, you just have to, what is minus? You have to not add, but subtract, okay. You have to subtract around 1700 years, and then you have the CalBC data. But like this, we can also see Kalba, the blue one, starts smoothly and then becomes a little bit chaotic. Tel Abrak, on the other hand, is already going nuts somehow. Kalba I can explain nicely because Kalba is on the outflow of the Arabian Gulf. Tel Abrak was first, then we have Shimel, and around the Straits of Hormuz we then find Kalba. And the waters of the Arabian Gulf are very dense, very heavy, very rich in salt. So they go to the seafloor and travel out of the Straits of Hormuz. And as in Kalba, the seafloor is still not very deep, they reach Kalba. So it seems, but this is a working hypothesis which came to my mind and which I still have to prove. It seems that we have a delay at Kalba because it becomes chaotic as well, but 200 years later. That of course it takes some time for the water from Tel Abrak and Shimel to reach Kalba. It's not like beam me up, Scotty, whoops, I'm in Kalba. It just takes some time, you know. It could also be, of course, some variation within the lagoons. We don't know about this. Maybe people did not always collect the shells at the supermarket right at the beginning of the lagoon, and the shells would travel each morning. Oh, this is my turn of being eaten. I will go to that point because they collect me there. So if we have a look at the lagoons, the microphone is like me getting smaller. We see Kalba in the north with a more or less smooth coastline, nice lagoon where we could suggest that the refreshment or the water is traveling quickly through the lagoon, so it homogenizes rather quickly. Tel Abrak down there, I also marked Al Quwain because of the lagoon. Tel Abrak, the people might have collected in Ajman, which is a bit to the south, or in Al Quwain, maybe when the sea level was higher, it was even easier to reach. But we see that Al Quwain lagoon is rather complicated. It's not a smooth system with an entrance and an outflow, but it's not a flat seafloor, but it's really varying. So of course, a shell that is being caught, now I would need the pointer. Oh, can you see there's a pointer? If we collect a shell here, it will of course be different to a shell here because it might see a different oxygen or carbon isotope. And of course, then we have variations in the radiocarbon of the shells within the lagoon. How can we get hold of this? I mean, this is not very encouraging, actually, when you try to date radiocarbon, when you try to do a radiocarbon delta R reservoir effect. Of course, the sea level plays a role because more water means better mixing, because then the depth is not the issue. So it reflects the sea level, but it also reflects the lagoonal differences. So we thought we'd do it or give it a go for stable isotopes. I've done that in Kalba to the right. The shell is about 6,000 years old, but as you can see, they build rings, they grow like trees, so we can also sample them like trees. We can sample over the year. And you see a nice periodicity in Kalba, in oxygen, which is the upper graph. Carbon-13 is the lower one, which is much more complex because it has several sources. But Shimel, on the other hand, does not seem to be very systematic or very periodic as in Kalba. So this also tells us something, and this is quite interesting. We have to check also the C13 signal, which seems to go down, whereas the oxygen seems to have a trend upwards, which usually means that the water is getting cooler. I mean, the Arabian Gulf is rather flat. So for the waters to get cooler, it would mean that the sea level has to rise to have a larger water body, which is more difficult to heat up. That the C13 is going down could then be a consequence of more limestone being dissolved. But these might be, this is Anadara, we also did some stable isotopes on Marcia, but that's not yet finished. So we will try to tackle the lagoonal variation or the explanation by also doing the stable isotopes on the shells of the lagoon, so maybe this brings us a step forward. So I'm already nearly finished. The conclusions are we have a wonderful data set from Schimmel, and Lloyd promised me some more samples, because I think it's a nice starting point. We can use the reservoir effect to follow sea level trends. We have to of course, get more data on sea level. This can be done differently, but I think it's a nice monitor as well. But of course, it is a multi-effect. It's like a criminal case when you find a dead person and you find a knife, you know it was stabbed, but that's it. If you don't go and look for genetic evidence, or maybe there is a cigarette, or there are footsteps, you will never know what really happened. So you have to really try whatever method you find, and then you will understand the processes that go on. So we'd like to tackle lagoonal variation with stable isotopes, also on Marcia and on Anadara. And if you have shells, feel free to get in touch, because I'd really like to monitor the sites along the coastlines in the Gulf of Oman and the Arabian Gulf to understand better the ocean circulation and the sea level patterns. So I would also like to thank the wonderful guy who is translating it into gesture language. So I admire what you do. Thank you. Very, very inspiring in that. Wow, I mean, it's even hard for me as a non-native speaker to know the words, but this is really amazing. So thank you for your help, and thank you for listening to my talk. Thank you.
Yeah, thank you very much. Yeah, you were absolutely on time, Susanna. Thanks so much. That was great, but please stay here. Are there any questions, the audience? Yes, please, Mark. Could somebody bring a microphone? Thank you.
Thank you. Great talk. For the Schimmel site where you showed, I think it was the oxygen increasing through time. Does that correlate to the Bronze Age levels?
No, it's only along the shell.
Right.
No, it's back. It was only, there were about 20, 30 holes in the shell, and this is the oxygen data per hole.
Okay, but the shell sample itself is from which layer?
It's from Schimmel.
From which chronology?
It was from Trench A.
Okay.
So it's Bronze Age, yeah.
Because we know in Abu Dhabi that in like Nar period, when you mentioned that the sea level has to be higher for it to be cooler indication, and I think in Nar and then some of our sites, Bronze Age sites along the coast of Abu Dhabi, the sea level height goes maybe about 1.25 meters higher than the present time. You have traces of the marine platform higher up, so we know sea level is a bit higher in the Bronze Age period, but that's 2000.
It could also be in a short phase, because I think the shell was not older than 5 years. So this is very high resolution compared to sea level over centuries. So maybe we can also have a higher resolution later in sea level when we have enough data to really make it statistically significant.
Yeah. Anyway, you should speak to Kevin Lidor. We have lots
we are
of
in
shells
contact,
and charcoal and things from some of the Abu Dhabi coastal sites.
Great.
It would be
that
good
would be nice, because it's also a complex
yeah,
lagoon.
just a bit further along west of the coast, because our impression is there is some variation between Northern Emirates, and because of lagoon situations and things, it's a bit different to barrier islands and the coast in the western
I would
region.
expect
So you
this,
need comparison.
Yeah, would be nice. Yeah, would be happy. Yeah.
Thank you.
Thank you.
So we still have some time. Is there another question, maybe? All right, then I would like to introduce the next speaker, Dr. Leslie Gregoritska. She's here, and she will be talking about developing isoscapes for Ras Al Khaimah and beyond.
All right, thank you all so much for being here. Perfect. So, biogeochemical analyses of ancient human teeth have allowed bioarchaeologists to explore prehistoric patterns of mobility and migration across southeastern Arabia. Nevertheless, the bioavailability of isotopes such as strontium in the UAE is not well understood, despite the need for such data in order to generate more nuanced interpretations of prehistoric human movement. This research seeks to develop a better understanding of isotope bioavailability in the region, particularly in Ras Al Khaimah, a haven for Middle Bronze Age communities following a rapid climate change event in the 2nd millennium BCE. Before we address the ways in which isotopes can shed light on the complexities of human movement in the past, it's important to clearly identify why archaeologists are interested in mobility in the first place. The ways in which human communities move affect how groups interact with one another, how they acquire resources, and more broadly, how they shape and are shaped by physical and social landscapes. These kinds of insights can in turn reveal broader patterns of social organization, social and ethnic identities, sex-based patterns of patrilocality or matrilocality, trade relations over land and sea, responses to climate stress, and long-term or permanent migration. In particular, examining the role of mobility during the Bronze Age in southeastern Arabia can over just a few hundred years. Isotopes from human skeletal remains can help bioarchaeologists to learn more about mobility, and these types of cultural shifts. However, in isolation, isotopes from human tissues have little meaning without broader context, and understanding the availability of isotopes in local ecosystems is critical to improving interpretations of human movement in the ancient world. So, where do we obtain this kind of context? The best way to approach this problem is by generating what are termed isoscapes. This term was coined by combining the words isotope and landscape and refers to a map of isotope distributions across a geographic space. The goal of such a map is not only to depict the spatial distribution of isotopes within a particular landscape, but to also predict what isotope ratios ancient humans may have possessed if they were local to a region, as opposed to those individuals who grew up in another location. These isoscapes thus enable bioarchaeologists to better understand patterns of mobility and migration in a given region. While a number of isotopes can be used to evaluate human movement in the past, strontium is most frequently relied upon by bioarchaeologists and was the focus of our investigation. For our purposes, we will be looking at the ratio of isotope strontium-87 to strontium-86. These isotopes originate in bedrock, and their ratios depend on the age of that rock and on the types of minerals that comprise it. Because different regions are composed of a variety of geologic sources and ages, These areas will produce strontium isotope ratios that differ across geographic spaces. Strontium isotopes are then released through the erosion of rock into local ecosystems, passing through sediment and water into plants. As animals consume these plants, and as humans consume both plants and animals, strontium isotopes become incorporated into their tissues. However, we cannot rely on the geology of a region alone when analyzing environmental samples to create an isoscape. In fact, isotope ratios from rock or the sediments that it produces are not particularly good predictors of strontium ratios in the organisms that inhabit that space. There are a variety of reasons for this, including the fact that different minerals within the same rock can vary greatly in their strontium isotopes, and that differential weathering of rock may produce soils with strontium ratios that are not reflective of underlying bedrock. Because of these problems, bioarchaeologists typically do not collect geologic samples when generating isoscapes. Instead, it is more prudent to examine strontium that would have been bioavailable to humans. Today, this is typically evaluated in one of two ways. We sample modern local plants, and we sample local animals. In particular, bioarchaeologists try to sample small, non-migratory mammals like rodents with limited home ranges, as fauna that graze over long distances may possess strontium ratios that do not reflect local ratios. Mapping isoscapes from plants or small animals will likewise help to capture the effects of aeolian and atmospheric deposits of strontium, whereas mapping primarily from underlying bedrock will not. To date, there have been no dedicated studies seeking to generate isoscapes for Ras Al Khaimah or the broader UAE. However, prior strontium isotope research has incorporated a small number of plant and animal samples to begin generating baseline data against which archaeological human strontium isotope ratios can be compared. In a 2017 publication, Cutterer and Ertmann sampled wood from 3 locations in Ras Al Khaimah, although plant species were not specified. In my own work, I have sampled archaeological sheep and goat teeth originating from both mortuary and settlement contexts at Schimmel. Again, however, we must be cautious about developing locally bioavailable strontium ranges from animals that may have grazed across long distances, even if they appear to be a good fit for the humans that also resided in this area. Due to the limited sampling done previously, we began a pilot study with the goal of developing a preliminary isoscape for Ras Al Khaimah by targeting local plants growing around the emirate. In addition to the issues surrounding the sampling of rock described previously, plants are more useful to sample than rock or sediment because their strontium ratios represent a more reliable and consistent measure of bioavailable strontium, as the uptake of strontium is averaged in their tissues. This averaging effect should therefore be more reflective of actual local strontium ranges. Sampling occurred from December 2023 through January 2024 as part of a broader, ongoing project directed by Professor Lloyd Weeks that seeks to investigate cultural change at Schimmel during the 2nd millennium BCE. A total of 72 plant samples were collected from 24 sites across Ras Al Khaimah, marked by red squares as shown here on the map. These sites were largely selected to capture the variability of underlying geology throughout the area, although trees in close proximity to archaeological sites were also sampled regardless of geologic age. These include numerous samples taken from Schimmel, Kat, Nudziba, Karnal Harf, and Daya Fort. Of the 24 sites sampled, 21 were analyzed based on available funding. The majority of samples came from the leaves of gaf, acacia, and cedar trees. Trees were selected to ensure the existence of more developed root systems that would be more representative of underlying geology and water. While it should be noted that acacia do tend to have shallower root systems, these were often the only plants available for sampling. When possible, samples were only taken from pristine locations that were unfarmed and undeveloped in order to avoid non-local sediments or contaminants such as fertilizer. Shown here is an excerpt from my data collection practices, which included species identification, geologic information, and geographic coordinates of each plant sampled. A handheld GPS unit, a Garmin eTrex 10, accurate up to plus or minus 2.13 meters, was used to record the location of each sample. As you can see from this spreadsheet, leaves from 3 to 4 plants in close proximity to one another were sampled at each site, no more than 500 meters apart. And here are just a few images of myself and Mr. Rahma El-Shamsi in the field, sampling plants and recording information about the site. Leaves from each plant were taken from 3 different heights to ensure a homogenized sample more representative of that particular location. Small branches, approximately 3 to 4 inches in length, were cut from each plant using pruning shears and placed into labeled bags. Moreover, as mentioned previously, samples from 3 to 4 plants in close proximity to one another were taken at each site, creating a composite sample of leaves from different plants. This kind of homogenized sampling helps to ameliorate the problem of relying on a single plant, whose ratio may not be representative of the place where it is growing. Plant samples were air-dried in low-density polyethylene bags to prevent decomposition and the accumulation of mold. Once samples were fully dry, leaves were removed from each twig. Samples were then transported to the United States. There, dried leaves were ashed in a muffle furnace before samples were prepared and analyzed using a thermal ionization mass spectrometer. So let's take a look at our initial results. This is a scatter plot, and you can see that the strontium isotope ratios are depicted along that y-axis. Each colored dot represents the strontium isotope ratio of the sampled plants at each of those 21 locations that I mentioned earlier. Overall, the mean ratio of the 63 plants sampled from these 21 sites is 0.70870. We then take the standard deviation around that mean and multiply it by 2 in order to generate an estimate of locally bioavailable strontium in Ras Al Khaimah. The area between the 2 dotted lines represents local ranges for RAK based on our results, and you can see that almost all of the plants we sampled fall into this range. We do have one notable outlier, however, from Nudziba. Now, if we remove this outlier from our calculations, we do see a reduced local strontium isotope range, but one that still encompasses nearly all plants sampled. We can break these data down into a few different ways as well. For example, we can look at the 14 trees sampled from 5 sites around Schimmel and find a relatively limited set of ratios depicted here in our scatter plot in blue. This narrow range contrasts against the wider variability represented by all sampled plants across Ras Al Khaimah, depicted in orange. So, despite similarities in mean, the wider distribution of strontium ratios in Ras Al Khaimah is important to take into account. So we can add complexity to these interpretations by pulling in the archaeological fauna that I previously sampled from both tombs and from the settlement at Schimmel, depicted here in gray in this revised scatter plot. You can immediately see that while there is some overlap with ratios generated by local plants, these ovicaprids clearly had a larger range and so also possessed higher strontium ratios. These ratios are statistically different from those of the plants at RAK. Okay, so now let's bring everything together and expand even further to include strontium isotope ratios from the plants sampled as part of this study, from the 3 wood samples from Rasselheimer analyzed by Cutterer and Ertmann, which are shown here in green, the archaeological fauna we just discussed on the previous slide, and now for the first time, archaeological human ratios from the Bronze Age tombs of Unar I, Unar II, and 4 Wadi Suk tombs, all of which are located at Schimmel. And I'll just note here that most of these ratios, including the plants from this study, as well as all individuals from Unar II, have not yet been published. If we now add our original ratio generated by plants from, or range, I'm sorry, from across Rasselheimer, we can see that plants actually capture a good amount of human ratios, suggesting that most individuals interred within these tombs were local. But at the same time, you can see that those dots representing plants fall much lower on the scatter plot than animals and humans. This differential either suggests that a number of individuals interred in Umanar tombs were non-local to the area, or that the people of Schimmel took advantage of resources not just from within that limited confines of the Schimmel plain, but also across Rasselheimer and perhaps the broader UAE. In fact, many of these individuals were likely consuming non-terrestrial resources that could account for their higher strontium ratios, including calcium-rich and therefore strontium-rich foods like shellfish and seaweed, which possess higher strontium ratios than fish and most cultivated foods like cereals and fruits. Marine products like seaweed could also have been used to fertilize crops or even to fodder their herds, which likewise would result in higher strontium ratios among both animals and humans. Regardless, however, the results demonstrate the potential for isoscape mapping to identify both small and larger scale mobility patterns using isotopes from human enamel and represent an important first step in the creation of isoscapes for the United Arab Emirates. In the future, we hope to expand on these data by including animals as well as plants in order to generate more accurate isoscapes for bioavailable strontium. In particular, we are interested in pursuing strontium ratios from small mammals like rodents so that these might be compared to plants and larger animals. Obtaining rodents so that their teeth might be sampled for strontium isotopes may involve trapping, or, as I actually began doing in Al Ain earlier this year, obtaining owl pellets that contain the remains of rodents, including mandibles with in situ teeth. And you can see one of the pellets that I dissected here, which includes a number of intact rodent bones that the pellet produced. And I'd like to end by acknowledging the funding sources, institutions, and individuals that made this research possible. Thank you very much.
Thank you so much. That was really interesting. I'm sure there are questions. Yes. Back maybe. No, there's a microphone on the way.
So thanks for a very interesting talk. With the results from the strontium, it struck me that the Wadi Suk range is actually more limited than the Umanar range, which is kind of opposite what we would expect if Wadi Suk was indeed more mobile, as is often assumed. Do you have an explanation? Is it just a sample size thing, or?
Sample size could certainly be a part of the issue, and I think that we certainly need more Wadi Suk human individuals to answer that question. Obviously, we think that there are pretty substantial differences in social organization, where we have, potentially a decentralization happening in the Wadi Suk period. But the acquisition of resources has also shifted in many ways, and that's being reflected in part in strontium isotope ratios. I haven't shown the oxygen and carbon isotope ratios, but those add additional complexity to that data and are probably beyond the scope of this paper, which just sort of focuses mainly on trying to identify bioavailable strontium in the region as a whole. But we're working on trying to figure out what might be going on with the Wadi Souk individuals for sure, and increasing that sample size will be a major aspect of that.
Hi, Leslie. Thank you. That was really interesting. Is there a way to model how much marine food someone would have to eat that would affect their strontium values in this way?
There is a way to model it. Unfortunately, we are unable to do so. So typically what we would do would be to sample carbon and nitrogen from collagen, and then sample also the carbon isotope values from bioapatite, from carbonate, and we would graph those against one another to look at levels of protein consumption specifically, but we are, unfortunately, as you probably know, unable to do that in this region, and so we don't have a good idea beyond contextual information of things like shell mounds and other evidence of subsistence that's not coming directly from the human skeleton.
Is it possible to use other examples from other contexts and then apply that here?
From other cultures?
Yes.
I think it's possible. I think it would be highly speculative, potentially, and so I don't know that mapping what we find in other cultures to what we're seeing here is going to give us the best results. I think certainly some comparisons could be more useful than others, though.
Thank you.
There was another question in the center lane.
Oh.
Can you get a microphone, please?
This is not a critique, it's just a curious question. Would the depth of where the trees retrieve groundwater affect the correlation between what is available for human consumption and what's available for tree consumption?
Yes, absolutely. And so in an ideal world, we would be measuring bioavailable strontium from plants that had different root levels, plants that had shallower roots, sort of medium, and then deeper roots. So whenever possible, we were sampling deeper roots to get more of that averaging effect of all of the age and then the sources of those different minerals that make up that geologic spectrum for that plant. As I mentioned, because most of the plants available were going to be acacia, those tend to have shallower root systems, and so that's why we want to bring in those animal samples just to make sure that what we're getting is actually representative.
Okay, and then just a quick cautionary tale. From South Scandinavia and Northwestern Europe, they just fairly recently found out that all their modern baselines were corrupted by the fact that intensive European agriculture has spread so much lime, and it's completely distorted the modern record. So they will have to go to ancient living tissue to establish a useful baseline. So you just so that people should avoid agricultural soils where lime is handled in large quantities.
Yeah, absolutely. And fortunately, so far, especially in Ras Al Khaimah, it was very easy to avoid those types of areas and to sample from kind of quote-unquote pristine locations where you don't have construction coming in where they may be bringing sediments from other places, or you don't have farming where you could be bringing in fertilizers that are going to alter the strontium isotope ratios of that local area. Absolutely.
Oh, Mark Beach, please.
Yeah, thank you. Great presentation. Just a note, we should sit together and increase your isoscape mapping. We have a project we've been doing where we've been sampling plants and soil samples between Al Ain all the way to the Saudi border. This is in relation to our camel project, the wild Neolithic camels in Baynuna, and we're working on that publication. It should come out soon. It's a collaboration actually with the laboratory that where Suzanne works, doing the samples, and so we've already got the isotope results, and so we can add some more mapping data for UAE, but it's good that we all sit together and increase the isotope map, because it would be interesting to compare the results, and we were interested in the mobility of the Neolithic, late Neolithic camels to see the range that they're spreading in, and as you pointed out, we only had the 3 points done by Hans-Peter Ertmann and his daughter. But now it's great that with your data and we'll publish our data coming up. It'll probably be Q2 next year when we finish all the papers, but it will help the general ice escape mapping of UAE, and we need to do more. Clearly.
That would be fantastic. Thank you so much.
But thank you for your presentation.
Yeah.
All right, thank you. I think so I would like to invite the next speaker, Guillaume Chung-To, who is going to speak about a GIS project, When Bone Meets GIS.
First of all, I would like to thank the organizers and the museum for hosting this seminar. So I would like to introduce you to a project carried out jointly with my colleague Hervé Monchot. It is a project to automate the representation of faunal remains using GIS. So just to clarify, I'm not an archaeologist. But as part of my PhD, I took part in several projects in Saudi Arabia and Oman, where I had the opportunity to discuss with Hervé about faunal remains for publication. While writing papers and monographs, I became aware of the use of this data, which did not always seem easy to access. At the same time, I was able to develop my skills in databases and GIS. Starting with data that can sometimes be a dry topic and difficult to approach, I bring my archaeologist perspective to the presentation of this raw data, evaluating the possibility of setting up a system for representing animal skeletons. The idea was therefore to standardize representations in order to facilitate the visualization and comparison of data, which requires extensive work on graphic semiology. This presentation is therefore primarily methodological, aiming to explain the objectives of this project and the steps necessary for its implementation. Archaeology is playing an increasing important role in the archaeological missions we are conducting across the Arabian Peninsula. Archaeology is proving to be the key to answering fundamental questions that go far beyond the simple question of what products were consumed, providing insights into actual social practices such as animal husbandry, food preferences, or taboo. The research conducted since 2017 by the Franco-Saudi mission in the oasis of Al-Bada, led by Guillaume Charloux, Samer Salah, and Abdullah Al-Tarib, offers an interesting set of data for an initial experiment and application of this tool. So in archaeology, data is traditionally represented in the form of skeletons. The quantity of each bone is represented in order to identify certain preferences or practices in animal consumption patterns. You can find this type of illustrations in papers, monographies, or other publications. The drawings are usually made using vector software, where each bone is colored by hand according to a color gradient that corresponds to the greater or lesser quantity of bone remains found in archaeological context. These representations also highlight certain data such as bone fragmentation, the presence of cut marks or burnt bones. These representations can be on the scale of a site, an excavation area, a trench by phases, etc. The idea behind this project is therefore to facilitate and automate the production of these skeletons, which are essential for giving a visual aspect to the raw data, and thus producing a meaningful illustration for reports and publications, allowing for instant visualization of data that is easier than lines of tables, especially for non-specialists. Indeed, producing these representations by hand is very time-consuming and adds to the already lengthy study of all the bone remains, the osteological observation. We must therefore stop filling in the skeletons manually, and data handling is made easier by the fact that it can be used for statistical analysis. It can be represented in a variety of ways. To this end, it was decided to set up a GIS. In short, a GIS is a geographic information system. It means a system that combines a database with a cartographic representation. Each information contained in the database is thus specialized, creating a kind of map. For several decades, this tool has been widely used in archaeology for the production of site maps, but also for special analyses, such as the distribution of sites, certain artifacts. To do this, it relies on quantitative or qualitative data. In our case, this mainly involves quantitative data relating to the number of bone remains found during excavations based on data produced by the archaeological study. The choice naturally fell on the free software QGIS. The principle of GIS is to specialize data. From there, it was necessary to turn the skeletons into a kind of map where each bone would correspond to a special entity. To help us in this process, we were fortunate that vectorized skeletons were already available in open access on Archaeozootech platform. The vectors for each bone were therefore extracted, integrated into a GIS, and converted into polygons with arbitrary specialization. There are two types of representations: profiles and exploded skeletons. After creating these skeletal maps, it was necessary to integrate the archaeological data essential for producing these representations. It was therefore decided to create a primary key in the database to individualize each bone. To do this, we started from what Hervé had already set up in his tables, in his database, namely a distinction between body parts. So the body part is representative of certain pieces of meat according to their nutritive ratio. A number was therefore added to each body part to distinguish each bone within the same body part. To go further and not limit ourselves to a representation of profiles, exploded skeletons were added. So the BP code, the primary key, was therefore incremented with a letter L or R to lateralize the bones in this last skeleton. And this primary key was added to a column in the table of faunal remains compiled by Hervé for the different projects, making it possible to associate each bone with the corresponding GIS polygon. The bones in this table have 4 levels of identification: the body part, the bone or fragment, the state of preservation, and the lateralization. So the most basic representation is the number of remains. However, a process of adjustment and experimentation was necessary, involving ongoing dialogue between the archaeologist and the GIS specialist in order to find the best mode of representation and the most appropriate representation for the information that we wanted to highlight and that was necessary for interpretation. So you can see on the 3 figures the same skeleton with the same data, but with a different statistical distribution. The greater the number of bone remains, the more the skeleton will tend towards the color red. For the categories, we stopped with 5 classes with natural breaks. So this method seeks to reduce the variance between classes and maximize the variance between classes. After this initial presentation of the tool and its aims, let us move on to a brief summary of the archaeological data that will enable us to apply skeletal representation. So Al-Bada is an oasis in the far northwest of Saudi Arabia. located in the province of Tabuk, not far from the Gulf of Aqaba. This oasis stretches 7 kilometers north-south, crossed by the Wadi Afal, and approximately 2 kilometers east-west, bounded by 2 mountain ranges. Mentioned in the text from the Islamic period under the name Madian, this oasis could be identified with the ancient biblical Midian associated with the story of Moses. Research conducted since 2017 has refined our knowledge of this oasis, which consists of several sites dating from different periods and allowing us to trace the occupation of the oasis over a long period of time from the Neolithic to the present day. The Neolithic assemblage is dominated by goats and sheep, the caprines, and the other species attest to the exploitation of wild terrestrial and marine resources. For the Bronze Age, goats and sheep still dominate, and the cattle appear, albeit in small numbers, and the relatively low diversity of species, you can see on the chart here, is largely due to the small size of the test pit at this site. For the first millennium BCE, so the site of Kala, we have the appearance of camel, the dromedary. And then during the Nabatean and Roman period, we have the appearance of pigs and chickens. It should be noted that chicken remains were found only in the elite residence and the fort, perhaps indicating that chickens were consumed by a certain segment of the population between the Nabatean and late Roman periods. At the beginning of Islam, chickens disappeared from the assemblage, and caprine still dominated, but a large proportion of dromedaries were also observed. A more detailed study of the dromedary remains suggests that these were probably pack animals whose carcasses were burnt rather than animals for meat consumption. All of these archaeological data shows a constant predominance of sheep and goats. However, cattle and marine resources are also present, although they are much less represented. The appearance of certain species can also be observed, such as cattle in the Bronze Age, dromedaries during the first millennium BCE, and pigs and chicken during the Nabatean period, probably linked to the Mediterranean world. Based on this data, it was interesting to see what mode of representation we can propose. To do this, we draw on a recent study conducted on the elite residence of Al-Malha II, occupied from the Nabatean period until the 4th century CE. So here you have a short video showing a restitution of the different architectural phases for this building. So GIS allows us to represent the spatial distribution of faunal remains in a fairly conventional way, namely the distribution by room of the number of remains according to the species, but also the distribution by room of the number of remains for each body part, in this example for caprine, and this highlights areas of rubbish in particular. We are therefore at the scale at the excavation unit here, so the residential, the house. If we move to the skeleton scale, we can represent the number of each type of bone for each phase, whether on a profile or exploded view. This kind reflected dietary preferences, but also biases in the representation of the assemblage. So you can see here for the 3 different phases of occupation of the house. We also attempted more elaborate representation showing as much information as possible. So we started with the NISP, so the representation of the number of bones. Then we had a representation with a number of cut marks and their location, and also the fragmentation ratio for the long bones. The same test was carried out on burnt bones found in large quantity at Malaha 1. They provide a better understanding of the context of the excavation, reflecting the practices of animal carcass incineration, in order to understand if the whole animal was burnt or only some waste from cooking or butchery. For example, in the early Islamic context of Al-Malaha 1, there is a high representation of camel compared to other areas and phases. But most of those bones are burnt, sometimes vitrified bones, and only one cut mark was identified. So these findings suggest that the overrepresentation of camels during this phase in this area does not reflect greater consumption, but rather the incineration of entire carcasses. Beyond simple representation, the advantage is also being able to compare this visual representation of archaeological data between areas, phases, and context. The same can be applied to reflect for example, the deficit of some bones, and that is an indication of taphonomic biases or choices in the selection of butchery pieces. The next stage of the project involves developing other modes of representation, particularly in terms of body parts, fragmented bones, and the age of individuals. The work will also be facilitated by the creation of summary tables that can be directly integrated into the GIS without having to re-enter all the data and create pivot tables. The aim is to offer a multiscalar representation in order to facilitate the interpretation work to be carried out by the archaeologists. At the same time, a statistical component will be developed in order to conduct more in-depth analysis. All these avenues for representation are currently under consideration. This tool will ultimately standardize and accelerate the production of skeletal representations for the different archaeological projects in the region. So we start with Taj, Dadan, Khaybar, Al-Bada. And we are, of course, open to any suggestions that could improve this mode of representation. The idea is to eventually make this tool freely available, and it will therefore continue to improve and should enable us to respond to various issues. Thank you for your attention.
Thank you very much. I'm sure there are questions. Who wants to start? Lloyd, please.
Thank you so much for that presentation. It was very interesting. And I noticed you focused very much on the graphical side of things, but you mentioned at the end that you were going to move into exploring the statistical potential of a GIS approach. And I was wondering if you could tell us just a little bit more about where that is going to go.
Now we try to develop a statistical analysis with a statistician. It's mostly on the, for example, about the age of the animals, because you know that for each bone you can identify if it's an immature or mature animal. So we try to make analysis on the length of the different bones and try to identify different data on the bones and make something more accurate thanks to this statistical analysis. At the same time, I showed that we did, for the moment, only natural breaks statistical analysis based on the QGIS software, but we'll try to find maybe a more accurate method to show the different results and to visualize easily the data.
Thanks so much.
So are there any more questions? Okay, then thank you very much again. And I would like to introduce the last speaker of this session, Giacomo Fontana. We will stay in the GIS evaluation and move to epigraphic landscapes in Saudi Arabia.
Thank you.
Please.
Perfect. Thank you. Yeah, thank you so much for having me today. Thank you so much for the organizer, for the museum, and also to the Heritage Commission for supporting this work. Today we will discuss about the epigraphical landscape of Hima, and how actually we understood the spatial structure of the landscape through quantitative methods. So indeed, this will be a heavily quantitative approach with a lot of statistics. I will not go in detail in the statistics, but I hope to bring you in the narrative with me. And this is actually part of a broader project that we are starting that is called the Mirage project. It's machine learning for the investigation of rock art and geospatial epigraphy. This is a project that has three components. One that is more explanatory, that is actually what we will discuss today. One that is a predictive model that we are actually now publishing. And another one, the last one, that is instead remote sensing for the detection of epigraphy, so deep convolutional neural networks, so AI. Hima. Hima is interesting because it was a trading post and a junction on the ancient caravan route that was connecting actually to the through the Rub al-Khali to the Levant and the Gulf. This actually is an area that's been investigated for the last 15 years by the Saudi-French archaeological and epigraphical project in Najran, directed by Alessia Prioletta, my co-author. In those 15 years, they were able to identify and record more than 22,000 epigraphy that are divided in 4,500 panels. So a huge amount of data that presents some challenges, because indeed, it's big data we're talking about. So it's difficult to understand those data on the broader level. And what we actually have, this presentation will focus on the characteristics of the script types, of the style, associated drawings, and the coordinates, of course, because it's spatial analysis. The two main dominant scripts that we have in the area that was already known is actually ancient Saudi Arabian and the Himaitic. That, as you can see from the dates, they overlap mainly around the mid-1st century BC up to the mid-1st century CE. And when we actually see at the landscape, we are talking about the region of Najran, so in the south of Saudi Arabia. And our research question was quite simple. Who are the societies that created this landscape? How actually they organize the landscape? How they're related with different environmental characteristics, with different territorial characteristics? And also, how does the rock art relate to the epigraphy? So, if there is a component there. The first very simple explanatory analysis was actually investigate the amount of epigraphy. And here you can already see the amount of them. We have actually the largest one, the largest corpus is the Himaitic. So panels that have only Himaitic, where we have around 650 of those panels. Then we have Saudi Arabian, that is the main component, where we have around 100. And then we have multi-scripts panels. So we have H plus S, Himaitic and Saudi Arabian, so panels with both scripts in the two languages. H plus M. M, in this case, is actually a script that has both characteristics of Saudi Arabian and Himaitic, and often it appears together with Himaitic, and then panels that have all three together. We have, of course, many other type of languages, but as you can see already from the distribution, there are much fewer. And here we go from Greek, we have a very broad range of those. So the first step was trying to understand what are them. So do a simple explanatory spatial statistics. Here, this is quite simple, or better, I hope it's quite simple. You can see there the distribution compared of those scripts, and the colors will always be the same through the presentation. So I ask you to focus on the orange, that is the Saudi Arabian, and what is the light green, the aqua, that is the Himaitic. On the spatial distribution, you can already see that there is, Saudi Arabian, they focus only on one part of the research area, while the other, they are much more capillary in the entirety of the research area. What you can see on the left is a segregation analysis, so it's simulation, Monte Carlo simulations. And what actually came out from this segregation analysis is that even though the distribution seems quite similar in many parts of those multi-script panels, we actually have very strong segregation. So we have the tendency of those panels to not appear together in the same areas, but instead to reject each other. When we do another simple exploratory analysis, we actually see that the large majority of panels are located on the western area of the research area, but with the exception of Saudi Arabia. Saudi Arabia instead seemed to be east, seemed to be located around 1.3 kilometers east compared to the other. And most importantly, when we have mixed panels, they tend to be located close to Himaitic. So very simple, we have at east Saudi Arabian, and then we have everything else that seems to be more at west. But those, of course, are quite simple analyses, so let's go in a little bit more depth. The next step was to understand why they're there. And this can be done in many ways. We can, of course, assess the cultural reasons behind the location of those panels, and we can also assess which is the landscape that created that. We will start with the landscape. Here, what we did was a point process model. This is a statistical technique used mainly in ecology to understand spatial distribution of points. It can be sites, can be epigraphy, can be everything. What we did, this is actually part of the variables that we developed for the predictive model. We have around 250 variables. Here we choose only 4. The first one is visual prominence. Very simple. How much a single area of the landscape is visible from the surrounding area. So if what it measures is actually if the epigraphy is very well visible, located in an area that is very prominent, or instead maybe is more secluded, in areas that are less visible across the landscape. Then least cost path density, very simple again. The movement of the corridor across the landscape. We did a million possible routes, and that measure actually which are the natural corridors of movement. Then we have topographical wetness, of course, measure the water capacity, which is the ability of people living in those areas. And then the eastness, that is actually, we saw that a lot of those panels are located at east. We also wanted to see if those panels look at east, or instead at west, so which is the orientation of those panels. What we did next, don't worry, I will not go into the statistic in all the graphs, but I will just go in which are the observation, the results of those. What we actually see is that the travel routes, they have a very strong connotation with Saudi Arabian panels. And this is actually incredibly strong because we are around 3 times Saudi Arabian panels in the 19th percentiles of the routes. And what is also more interesting is that Himaitic panels, even though there are 650, there are so many more, they actually are located only around on 1.54% of the areas where we have Saudi Arabian panels. So it's really clear that here we have a strong trade marker of route marker with the Saudi Arabian panels. And instead, the Himaitic, they seem to be occupying a much broader landscape, a much more capillary landscape compared to them. When we see the visual prominence, we have something different. Here we have again that the multi-script panels, they are located in the area that are the most prominent in the landscape. So Saudi Arabian and Himaitic in isolation, they are more secluded. Instead, when we have those panels all together, they're really actually in areas that are very well visible in different ways, as we will see through the presentation. Topographical wetness and eastness actually they didn't show a lot of interesting insights. Those seem to be more topographical variables. So all the panels are located in similar areas with water capacity, and also the eastness, we have around 50% of west, the east, so there is not much to say about this. What we have so far, though, is that we seem to have 2 inscription strategies. Saudi Arabian are clearly related with trade, with roots, with roots in the landscape. Route more than trade. Himaitic, instead, they have a much more variable location across the landscape. They occupy many different niches, and they seem to be actually located in order to claim a much broader territory compared to what is the Saudi Arabian. What is actually the mark of a more settled community. Multi-script panels, instead, they are the ones that are the most visible. So again, in those very high prominent locations, and the function of them clearly different from the others. Once we understand a little bit this relation with those environmental characteristics, we can take them into considerations and then apply statistics in order to understand if those panels reject one another. So to understand how the community structured those panels and what they do with them in order to organize the territory, the socio-political territory. This is point process model that is really, raw point, very statistical. I will try to, what we did here was a lot of Monte Carlo simulation, if you know what it is actually simulate patterns in order to understand if there is statistical significance and, provide insights that are very robust in that sense. What we also developed here was a Thomas cluster process. This is a common cluster that what actually it is in very simple words. Imagine a group of people living in an area. They have a neighborhood. They have a center in the neighborhood, and they behave in their neighborhood. So for us, the neighborhood is the radius of this, And the amount of panels, the amount of activity that they do is actually indeed the proxy for the activity of that. In the left of the image, you can see the statistic, how well the territory explains the distribution of our panels. And on the left, you see there are a bunch of color, and that indicate that is not really, it doesn't explain that very well. When we actually put the territory together with the cluster, the Thomas cluster process, you see that the color is very much within the envelope, the gray envelope, and that means that it's actually explaining very well the distribution. So we are around 85 to actually 100% of the full explanation. So, which are those models that we applied? We will focus on Himaitic and Saudi Arabian again. Those are territorial models. What we have is that Saudi Arabian occupy very small territories compared to the Himaitic, and they have very few panels in those territories. You can see a model, a simulation of the model. You see there are like bubble of occupation across the area. So we have few inscription per area. Again, we are root focused. So we interpret that pattern, those bubbles and those gaps in the middle, as what could be temporal camps. So, something much more temporary and ephemeral, if you want, in the landscape. So maybe a mark of mobile communities. The Himaitic territories instead are much larger, and they often overlap with one another in order to create a much more capillary and dense habitation of the area. And again, we have many more panels, many more intensity of those inscriptions in the landscape that seem to be much more zone focused in the sense that they focus in the entirety of the zone. Again, those fit better, also from ethnographic perspective, fit better what are the marks of more permanent communities, more local maybe communities living in the landscape. The multi-script panels, and this is just a summary table. Again, here what we see is that when those panels with multi-script, they have Saudi Arabian, they still focus on roots. And you see that they have a strong association with roots and also with visibility, especially H plus S and H plus S plus M. So those are actually contact areas. It's very clear from the analysis. Those are areas that, where the different communities interact with one another. H plus M is different because we have very low correlation instead with roots. We have very low correlation with visibility. Those are actually local use. Those are in the, in the more hidden area of the landscape. Those are the ones that you really need to know the landscape and live through the landscape to see. So it's interesting because it's a multi-script panel, but it's actually clearly used for the local Himaitic communities instead of the Saudi Arabian one that the analysis is showing are maybe more mobile. Once we have a better understanding of how the epigraphy act in the landscape, create the landscape, we also wanted to understand the correlation with rock art to the epigraphy. Here again, I will not go in detail in the graphs, I apologize for that. What we have mainly is that we have around 20% of epigraphy with rock arts. So 20% of the panels, they also have rock art, 1 out of 5. What is interesting is that the 5 drawing types, the 5 most common are camels, we'll say not surprising. Then we have bovine and ibex that we interpret maybe more connected to pastoralism, more connected to people maybe live in the landscape. And then we have armed figures and human figures. And armed figures are quite interesting in this optic. Again, we have the large majority of rock art in those panels that are the most visible in the landscape. So those multi-script panels. And when you see actually the broader distribution, you see that actually the quantity of epigraphy correlated, the quantity of rock art compared to the epigraphy act quite similarly across all different script types, with one exception, armed figures. Armed figures, there are statistically many more of them. There are many more of them when we have H and S panels alone. This is actually a collocation quotient drawing. What it is actually an analysis that measures how often rock art appear with single type of scripts, if that is more or less than what would be the random distribution, the statistical norm, let's say. So in red, you see when actually there are many more rock arts than what we could expect. In blue, when there are many less. And with the asterisks, you see when it's actually statistically significant. This is the next slide, we'll have the same image. So what we have here, Saudi Arabian societies, Saudi Arabian scripts clearly do not have a lot of rock art. It's the only one where the entire column is very much blue. We clearly have not much use of rock art with those societies. What we instead have, when we have actually multi-script panels with Himaitic, Saudi Arabian, and also M, we actually have huge hotspots where all the rock arts, again, they appear much more and also in a statistical way much more than what we would expect. At the same time, when we have H&M, we actually is interesting because we do not have any armed figure in those, not any, but we have much fewer of them compared to which are the other distributions. And what we also have is the presence, for instance, of a higher quantity of ibex and bovine. So something that, again, will fit with the idea that maybe those are panels used by the local communities. Instead, when we have scripts with Himaitic and Saudi Arabian, we have something very different. Here we have a much higher quantity of armed figures compared than what we would expect. And this is interesting because actually it also fits with the idea that we actually do not have ibex and bovine in those areas. And what I think it is probably those are specific scripts that were used to mark territoriality maybe, or maybe areas of, maybe negotiate the tension that could have been in the landscape with those multi-script panels and those armed figures maybe. So to conclude, what is the statistics saying? Okay, the findings themselves show a high amount of spatial segregation. And that's already interesting because if you see the simple distributions, it would be difficult to say that. What we also see is that there is a very strong connotation of Saudi Arabian panels with roots and Himaitic instead with a much broader range of niche across the territories. What we have is Saudi Arabian occupies small, and we have a light use in the area, so something that, again, can be maybe more temporal. And instead, Himaitic, we have a much larger landscape with a much more intensive use of the landscape. What we also have is that, again, Saudi Arabian, when we have Saudi Arabian in any type of multi-script panel, they really mark trade routes. But again, we actually have, if you remember at the start of presentation, all those multi-scripts, they seem to be more in the sphere of Himaitic compared to Saudi Arabian. So it's really like Saudi Arabian going toward the territory of Himaitic in this sense. And then we have the problem of the armed figures that we need to explain. So Himaitic and Saudi Arabian together. So which is the interpretation that we have right now? What we have is actually a landscape that reveals the spatial organization that's much more complex than what we thought. We clearly have, again, Saudi Arabian connected to root-based communities that interact instead with local one. The Himaitic, clearly, I think, from a landscape level, from an organization of the landscape, they clearly show a much more capillary use of different parts of the landscape, and also already the creation of those panels in much more secluded area, I think is quite interesting because really show that those panels were for them, not toward other communities that were passing by. It's very different, the strategy behind. What we also have is, again, this maybe mark of territoriality. So those armed figures, this abundance of armed figures, this higher amount statistical than what we could expect, it showed that probably those interaction area with Himaitic and Saudi Arabian panels alone were used instead, indeed, to negotiate the relation between those two communities. Then instead, when we have all the scripts together, we have rich palimpsests that also have a huge amount of rock art, and instead they seem to be maybe more like the meeting point, if you want, in that sense. What I hope that I showed also with this presentation is how maybe a more quantitative approach can also actually work together with a more qualitative that has been what has been used so far in this area to show some hidden strategies and also this territorial organization and quantify the territorial organization behind those distributions. Right now, we are actually finishing up the paper about this. We are actually implementing also the diachronic investigation in the territorial distribution of Saudi Arabian inscription to see if those change through time and maybe show pattern of use or not, or different use of different locations. And we are also understanding better the relationship between common and curvilinear, that are two different styles of the Himaitic scripts. Thank you so much for your attention.
Thank you very much. Are there any questions? Did you scare everyone?
Yeah, I think so.
There's a question.
Hi. Thank you very much. I was wondering, you mentioned that, well, do you postulate that Himaitic is strictly contemporary with South Arabian, chronologically speaking? And how do you determine that? And from there, the areas where you have both Himaitic and South Arabian scripts are areas where you mention territoriality of Himite, if I can call them that way, with warrior scenes. Does that imply conflictuality between both populations, if indeed both are chronologically contemporary?
The first question, there is my co-author that probably is, she's the epigraphist, so yeah. When I say territoriality, though, starting from the latter, I don't necessarily see conflict, war in that sense, but it can also be like in many other cultures, those are like, palimpsests just to negotiate territoriality and to negotiate maybe those, to avoid conflict, you show those things. So in a way, it can be a way to avoid conflict more than a way to actually, express conflict.
Yeah, thank you very much for your question. Concerning the chronology, it's very difficult to say in the sense that while we are able to date the ancient South Arabian inscriptions, even though in quite large period of time, we are still not able to give precise dates on Himaitic. So the temporal span that Giacomo showed mainly concern ancient South Arabian inscriptions, and within this quite large temporal span that goes from around the 7th century BC to late antiquity, even 6th century AD, we place the Himaitic inscriptions, and in the rare cases where there are, for example, some superimpositions on the panels, we are able to see that Himaitic texts are more ancient than, or precede even ancient South Arabian inscriptions that we date around something like the 2nd century BC. And that, on the other hand, there are panels containing late ancient South Arabian inscriptions, like from the 4th to the 6th century AD, where we've also find Himaitic inscriptions. But of course, as you know, it's very difficult to evaluate the relationship, the relative chronology on the panel. We can rely, of course, on overlapping, but it's also sometimes on the patina of the text, where it's very tricky. So I think a way to say more about the chronology of Himaitic inscriptions is also what with Giacomo we intend to do, which is to, if possible, to study the let's say, the paleographic evolution of the scripts, and especially the two varieties that he talked about, which are the common and the curvilinear Himaitic, and see at least which is the relationship between the two, if the curvilinear Himaitic is contemporary with the common Himaitic, which is the vast majority of the inscriptions. But right now, it's very difficult to answer to your question.
There's time for another question.
Great talk, Giacomo, grazie. With the data set that you put together and the kind of protocol that you studied, is it possible, do you think it's possible to predict the location of similar scripts and rock art panels in unsurveyed areas? I assume there are unsurveyed areas in the region, at least.
We did that. Part of the work is predictive modeling. Actually, we did we used this data set, and then we used transfer learning, that is a process of machine learning, to predict the location of epigraphy in the Tabuk area, in much northern in Saudi Arabia. And actually, the validation that we did with the data, the field data, we didn't use any data from that area. We just used that to validate. It appeared very effective. Okay. So I believe it's interesting because I usually do predictive modeling for archaeological sites that work in a different verticality. It's much more horizontal in that sense. But it actually appeared that there were the same, we can say that in the same area, there are probably the same cultural reasons behind the location of the epigraphy. Mm-hmm. And so for that reason, probably it was very effective in predicting that. If there is an area with completely different cultural reasons, I would not expect that. Of course, it's very good in predicting.
Okay, thanks.
Okay, thank you very much for this interesting presentation. And we have come to the end of the session, so I'm closing it. We will have another online presentation here now in a few minutes after a short technical break. The online presentation is connected to it's part of the Bahrain session for the ones who haven't seen it in the program. All right, so it is happening. So the last speaker, as I said, of this day today, the first day of this wonderful conference, will be Timothy Insol. It's an online presentation, and he'll be exploring the church in the East, the Church of the East in the Gulf. And I welcome the speaker online.
Thank you very much. Can you hear me okay? Because we've had a few technical problems. If you can just hold a thumbs up, then I'll know that everything is okay. And also, if I could see the presentation, please. Okay, well, good afternoon, everyone. You've already had the title. It's Exploring the Church of the East in the Gulf, the results of the Anglo-Bahraini excavations at Samahij in Bahrain. Next slide, please. So first of all, I'd like to thank the organisers, particularly as there appears to be every technical problem that you could imagine in my actually being able to make this presentation today. And I would also apologise for not being able to be there in person. What I want to do today is just briefly to introduce you to the 4 seasons of excavations that we've completed at Samahij in Bahrain. And this was in 2019. Then, of course, there was COVID year, and then between 2021 and 2023. And I would emphasise that very much it is a partnership project with Baka and also with the local community. And there are numerous individuals that have been involved. So though I'm presenting today myself, it of course is a team effort. So I would begin by outlining the location, which I think would be well known to most people in this conference. So here is Bahrain, obviously. This is Awal, the main island. This is Muharak, small island to the north. And in the north of Muharak Island, you have Samahij, the site that I'm going to be talking about today. Next slide, please. So the research aims were firstly to examine the past Christian presence in Bahrain, for which we lacked archaeological evidence. Secondly, to assess the late antique to early Islamic transition. And thirdly, to identify, if possible, the location of Mashmahig. Next slide, please. And there was a clue. It wasn't just a blind stab in the dark that Samahij might be the location, because it's possible that Samahij was derived from the word Mashmahig or Mashmahig, which was the name of a bishop's seat referred to in the synods of the Church of the East, sometimes referred to as the Nestorian Church, in 410 and 576. And this was possibly the most important diocese within the region known as Bet Tribe, which is in the northeastern Gulf. And whilst I admit that Wikipedia is not the most reliable source, it is surprising that in this map of bishoprics of the Church of the East that Bet Tribe is actually omitted. So we would hope that soon it will be added on to there. Next slide, please. Now, the relevant Syriac and Arabic historical sources have obviously been extensively explored, notably by the French historians Beaucamp and Robin in 1983, with their excellent paper making the link between Samahij and Mashmahig. It also interestingly seems to persist on maps. So if you see here this map from the late 18th century in this book here, you can see that we have a reference to Samaka. Now that could of course be fish, but it could also be a reference to Samahij, and this is something that repeats in historical maps of the Gulf. Next slide, please. Next slide, please. However, though we have the historical sources, substantive archaeological evidence for the Christian presence was lacking. And this was rectified by local information. This is the village of Samahij, you can see here. And local observers said that their mound at the centre of their village cemetery was possibly the remains of a Christian cemetery. And on top of it, there were the remains of a much later 17th to 18th century ruined mosque, the Sheikh Malik Mosque. Next slide, please. And the locals are absolutely correct. So this is the yellow outline, is the later shrine that you can see here. And underneath is the Christian building that we've uncovered with its walls outlined in red. So it's about 12 meters across here, about 16.5 meters across here, with primary mid-5th to mid-8th century chronology, which we've reconstructed based on 7 AMS dates, and also obviously on the ceramics and artifacts recovered as well. And I would emphasize that this is significant because it is the first archaeological evidence for Christianity in Bahrain. Next slide, please. What it isn't is a church. It possibly is a monastery, but I think it's much more likely that what it is a rich residence. And I would suggest that it is possibly the bishop's palace that was connected with Mashmahig. And I say this partly on the basis of the architecture, which is of exceptional quality. You can see it in the images here. Stone thresholds, elaborate foundations, well-finished door surrounds with door pivots. You can see in the central photograph there, there's one of these door pivots highlighted with an arrow. And it was also a very challenging site to excavate because, as you've seen, it's in an active cemetery and there are graves cutting into the walls of the Christian cemetery, which obviously we did not disturb. And this was made easier by the fact that they're in the form of stone boxes, as you can see on the right-hand side, which we left untouched. Next slide, please. And this is part of a much larger contemporary settlement. We're not able to investigate further because of the graves. You can see the proximity of the graves on the edge of the photograph. We're also not able to do geophysics. The community didn't want us to do this because they said that too is invasive and you would see the deceased, which of course we respect. But within our building, which we were able to excavate, we found 8 different rooms, which I won't enumerate individually here, but we'll now talk a little bit about more in detail. Next slide, please. So one of these, room number 1, up in the upper right-hand corner of the building, was a workroom or storeroom. It's accessed by a single door. Unfortunately, I don't have the functionality of my mouse to show you where the doorway is, but I think you can see it. And inside it, there were multiple plaster floors that incorporated rubbish. And in particular, items that appear to be linked with textile production, which is interesting, such as copper needles and also spindle whorls, like the examples that you could see there. And this is suggestive that one of the activities in this building was the production of textiles. Next slide, please. Second important room was the long room, number 2, which we suggest was the refectory based on its size, which is about 7 by 2.5 meters. And also because in the wall on the right-hand side of the room, you can see that there are peg marks in the plaster in the top left photograph. And I think that these were left by wooden fittings, which themselves have disappeared, perhaps like benches or something like that for communal eating. The alternative, of course, is that it's a church or a chapel, but the consensus is that the orientation is wrong compared to other examples from the Gulf. So the refectory seems most likely as an interpretation. Next slide, please. Next to the refectory, room number 7 on the bottom right, was a kitchen. And inside here, we found multiple halves that were formed both of burnt patches of charcoal, but also of reused bases of torpedo jars. And you can see one of these torpedo jars or amphora in the top left image. And the wall of this Christian, interestingly, had been of this Christian built kitchen, if I can put it like that, had been built on top of a late Dilmun tub burial. You can see it here. It's been destroyed by the later wall. And this is one of these tub burials that's inside the collections on display in the Bahrain National Museum. Next slide, please. And the earlier phase in this kitchen room is very interesting because we found traces of a circular structure. You can see it here. Sorry, I'm using my arrow, but you can't see it. But you will have to take my word for it that there are the remains of circular plasterwork that you can see. What this was, we're unclear about. I mean, it could be a roundhouse. it could be a silo, it could be an immersive baptismal font. And here I would draw parallels with the Sinir Island, Tim Power's work there, and the photograph there on the right-hand side. But we really don't know. And what a baptismal font would be doing in this location is unclear. So that is undecided. Next slide, please. The living rooms were at the heart of the building, and they're room numbers 4 and 5. They're centrally located and they're linked together by a doorway. These were by far the most richly decorated. They have all sorts of stucco work that had exfoliated or been chipped off the walls, a mixture of both. You can see one of the patterns at the top left, and also included some of the markers of Christianity. So this cross that had been thrown over the wall out of the living rooms across the mihrab, what would be the mihrab of the later Islamic building, and then just dumped there where we recovered it. Next slide, please. And this was one of the markers of Christianity. You can see another cross there on the right of stucco. You can see a small plaster portable cross on the bottom center, then a sherd with a cross marked on it that is Coptic ware, we think. And then at the top, after sorting through several thousand pieces of plaster, most of which were uninscribed, I found these two, one of which is marked with the key row symbol on the left, and the other with a fish in the center, upper center photograph, which of course both are early symbols of Christianity. Next slide, please. And other markers of Christian identity included diet, lots and lots of pig bone. This is one of the pig jaw bones that came out of the workroom floor that you can see me holding in the photograph on the upper right, and then it's in situ on the upper left. Strontium isotope analysis by colleagues here in the University of Exeter indicated that the pigs were being raised locally. They were being raised on the island of Awal, the big island to the south of Muharraq. And Jane Gastra's analysis has shown that this was part of a range of species that were being consumed, including large quantities of fish and turtle. And we were also sampled for archaeobotany, and Vladimir Dabrowski is working on this, and I believe is giving a paper on this aspect of the research at the seminar, so you'll hear something about it in comparative perspective. Next slide, please. Artifacts were various and numerous. At the upper left is a torpedo jar sherd with a tentative Syriac inscription on it, with a couple of letters identified by a colleague here in Exeter, which is another indirect marker of Christian links. In the center, we have a torpedo jar sherd with a marker of some sort, maybe an owner's mark or a mark indicating a commodity. And these ceramics are part of a large assemblage that's being analysed by my colleague, Nick Tate. On the right, I would highlight that as one of the most interesting artifacts that we recovered. It's a piece of pearl shell that you can see that's had a face etched on it, which I presume is a toy. And it's been marked with bitumen. And as far as I'm aware, it's a unique artifact. I don't know of any parallels for it. And the beads down on the bottom, you can see, were all of carnelian from the original occupation deposits, and including the etched example on the left-hand side in the photograph. And this is part of the evidence indicating significant Indian and Iraqi contacts. Next slide, please. The glass forms part of the components of what St. John Simpson has defined as a Sasanian assemblage, particularly in regard to the wart or blob decoration that you can see in numbers 3 and 4, for example, on the photograph on the right-hand side. Wine glasses also there, another indirect marker of Christian presence. And 12 eroded copper coins, one of which I show you here, because you can see that there's a mark of decoration clear on it, which appears to be one of the headdresses of the Sasanian type coin that you can see on the right. Not that exact coin, but along those sorts of lines of the Sasanian coin on the right. Next slide, please. And this isn't unique either in Bahrain, I would say. We know the location of another Christian complete settlement. Unfortunately, I'm not yet allowed to investigate it or to identify where it is, but that stone cross that you can see on the left-hand side is from that site. There are also 2 ivory crosses from Muharraq town that I think Samantha Dobson, who's just finished her PhD on this material, talked about. They were from late deposits, but they seem to be linked to an earlier phase that was had a significant Christian presence in Muharraq town as well. So it's far from an isolated incident. Next slide, please. And of course, it's part of a much wider picture of Church of the East foundations in the Gulf, which are now being well explored by many colleagues. And again, I think you've heard about Al-Qasr from Julie Beaugrand, Sirbani Yas from Maria Gajewska, and also Sinir, of course, from Tim Power. And the stars indicate some of the locations, and the numbers will only grow, I'm sure, of this particular phase in the history of the Gulf. Next slide, please. And then, of course, the Christian community disappears. It lasts until about the mid-8th century in Samahij. Then the people convert to Islam, which this longevity challenges a notion of instantaneous conversion. And I think what's also interesting here is that Church of the East theology may have facilitated conversion to Islam, because there were, of course, differences in the nature of Christ in the beliefs of the Nestorians or Church of the East. And Nestorius stressed the independence of the divine and human natures of Christ. And in this image on the left, you can see him being expelled, being condemned by Emperor Theodosius. And Christ is represented as God-inspired, not God-made. And David Nicholl, that famous historian of Islamic military technology, has argued in one of his books, particularly a book on Manzikert, the Battle of Manzikert, that this has implications for conversion to Islam because Jesus was a divinely inspired man. In other words, not exactly the Son of God, the physical matter of God. In other words, a prophet, which may have facilitated conversion to Islam. Next slide, please. And the next steps. In the photograph on the left, you can see that the site is now being restored and readied for public presentation, which is great. So you will hopefully be able to visit it very soon. We're redoing the section in the Bahrain National Museum, which the Tylos section, because now, of course, we have the Christian material to add into it, hence the photograph on the right. And we're working on a group application with colleagues from Kuwait and the United Arab Emirates on a UNESCO listing application for these sites. So exciting prospects for the future. Next slide, please. So in conclusion, this is remarkable archaeological evidence, I would argue, that's emerging from Samahij, but I would emphasize that its investigation is only possible because of the local community. And we've involved them in every stage of the research, as you can see from the photographs here, with community engagement days, and they take a pride in having this Christian legacy in their village. So I would end by
So thank you very much. I don't know if the speaker is still with us. Probably not. Or if he would be able to hear questions. No, but this is not the case. So thank you very much for attending. And we look forward to tomorrow. And I wish a wonderful evening to everyone. Thank you.